Hello everyone, welcome to another stream. Hi there, Remco. How you doing?
Hello, make it. Welcome to the stream.
I've never had anyone welcome me to a stream, but it feels nice, you know? It does feel nice.
It's a first.
Yeah, it feels really nice. Feels like I'm welcomed. That's nice. Yeah. How you doing? How's your day going?
Good. I have been studying on my melons.
Oh, how are the studies going?
Um, I'm getting progressively more angry with other people calling them settling suns. Other than that, it's fine. It's going great.
Well, that's good. That's good then. Wanna talk Feynman diagrams? Because I did title today's live stream working on free videos. And if I just work on the LEDs and the particle physics, that's gonna be two. I need to add a third one. To not clickbait, you know.
I think clickbait is personally reasonable.
Hold on, because I've been I got to like the beginnings of the fields. So right here, this is just me showing off that a fluctuating field like this. The line is the field. This is the Dirac field of electrons. And
That looks cool though.
yeah, it's nice because it's the way I did it actually is gonna be really pleasing because right here, this is just like a wave packet. I could package it, I guess. Yeah, I suppose I could package this. This is time. Hold on, time. So come together, top ones together. Okay, it packages nicely, which means that. Wait, why are the two outputs? No, one output. Math multiply. Okay, hold on. Let me just fix this up a bit. This right here. Top one. Remove the second output. What are you making? I am making a video about particle physics. A particle physics video in which we talk about particle physics. And then how do we shift things? We shift them by subtracting from the x, which means right here, subtract this. And now, there we go. It can move. So now what we can do is we can take this, plug it in like so, add them both together, and move it to the left. And like right here, we have two photons we can move. Well, let me give you a stream on Discord so that you'll be able to see it better. There we go. So this would be, for example, like, two gluons or something, or two photons or two electrons or whatever. And we can move them.
Ooh.
So this would be just two electrons, and this would be a sigma bond.
Oh, this looks cool.
Yeah, it's quite neat, isn't it?
But initially, I thought the little sphere in the background was like the representation of the particle.
What do you mean, this?
Yeah.
Oh no, this is just a focal point. This is the thing that...
Yeah, it's just your axis.
Yeah, but I mean, I did have an electron in the middle a second ago simply because I'm just gonna have like pop it on... Hi, the macaroni. I'm just gonna have
Hello.
it appear on screen for a second to show off that like that wave packet is the particle from before. But yeah, I think this would be pretty nice. And so then, when we'll have, for example, photons going in between the two electrons, then I'll just have like a separate field in front of it, and then I'll just have the wave oscillating back and forth, back and forth. But for now, right here, this is just a singular wave. It is quite neat.
I like it. It's good representation.
Thank you. The main reason why I'm so motivated to work on this video is because I am really happy with this idea of how to represent them. Where's the stream intro thingy song? It's really good. You mean the Make It theme? You mean this? But the jazz dub version. Yes, it's one of them. I don't remember which one. There's a couple. I'm losing track. Because your particles could be tempted to think that electron is a particle. I mean, no, it's a particle. But in case we'd rather think of it as excitations in the field. Basically, imagine our entire universe as being one-dimensional. Just a singular line where you can go right or wrong. Is the only options. Then we just have to particle to watch and point the ball. Yeah, that's sort of. Just the sake, but in reality, these particle axes, if you rather, that's what they are. Theory and the first quantization, hence the name. Oh, by the way, okay, there's actually one sentence. I would need your confirmation on Duranko. Because I scripted it as, rather, that's what they are in quantum field theory. Like, particles are excitations in quantum field theory. And the process of saying that this excitation is a particle is effectively quantization. Is that fair to say?
Wait, say that again?
The process of saying that this excitation in a field is a particle is effectively quantization. So, you know, what I mean here is that when you have like a wave packet in a field, treating that wave packet as if it's a singular particle is quantization.
That is not accurate, unfortunately.
Okay, let me change it then.
The whole prospect of quantization comes in when you consider particle creation and annihilation. You need operators for that, and these operators are quantized.
Okay.
So the quantization part about this is that you are able to create this out of the vacuum, this wave packet.
I see.
And you can, like, what's quantized is that you can create another wave package out of the vacuum. So, and there's nothing like in between a wave package.
So you cannot create half a wave packet.
Yeah, that's the quantization part about it. Sorry to disappoint you, Shenton.
No, it's fine. I'm just thinking of a way to tie it in now. This. Okay, but it would be a quanta of the field.
This is one quanta, yeah. So yeah, that's the whole thing. This is one quanta. You can have another quanta, which is just another wave package. But you can't have 1.5 quanta.
Field.
I love that the word quanta is such a nice way of saying that something is quantized, almost like it's made for that.
Quanta always really nicely clicked in my brain. I like that word. It's one of those words where you hear it and you know exactly what it means.
Mm-hmm.
You know, it's kind of like classic. You know, it's like Brussels sprouts. You hear the word Brussels sprout and that's exactly what those are. They're Brussels sprouts. It's brilliant. Okay, now
Straight to the point.
exactly. They are in the quantum field theory. They are quanta. Okay, so right here, all I'm gonna do is I'm just gonna have the text QFT up here, and then I'm gonna do the quanta of a field, and I'm just gonna have an arrow pointing at the Q and the F. Just once again, quantum field theory. Also,
I mean, when you talk about quanta, what you could do is like have this sphere in the background flicker, so that looks like a particle.
yeah, I was gonna
like
yes.
Yes.
That's
I love our way of thinking. It's great.
Okay.
By the way, if you want to see what I'm doing,
Yeah, do show. By the way, BDS, how are your days going? All right. I can show it on stream, right?
yeah, of course.
Thank goodness, because the window opened on stream and I got a heart like, oh, never mind, I did disable the view. It's fine. Okay. Oh, thank goodness I am. that's a lot. Why is there so many? Oh, couldn't have. Wait, 4. Is that the Hold on, I can pull it off. It's. I remember seeing the four combined wave functions to get the wave function in the Valet textbook. Is it
Wait,
the?
what are you talking about?
Can I just bring up a page of one textbook and can you tell me if the reason why you have the four wave functions there is the same as from the textbook? Give me a second, you'll see.
Keep in mind, these are not wave functions, but fermions.
The psi on the sides, there's no.
Essentially, it's kind of a sort of wave function, but it's not the wave function in the most traditional
Oh
sense.
no, that's IJKL, isn't it? Oh, jeez, that's really small. Hold on. Oh, that is IJKL.
You want me to zoom in?
Okay, that may bother me. Hold on. View textbooks. There's only one place where I've seen specifically four wave functions combined, and it just like it was the neuron activation meme, you know? Just
Show me. I'm curious now about the paper. Wait, yeah.
it was from a
I am
Valet.
watching
It was
this.
just from a Valet textbook. Give me a second. Quantum mechanics. No, wait, it was the particle physics one. Oh, also, how much do you know about the weak interaction and just the flavors? Jeez, my brain is working slowly today.
I want to say not that much, but now I've done quantum field theory. I can't say not that much. It is just quantum field theory. I am better at the weak interaction and the strong interaction.
Remember yesterday, by the way, when I posted the screenshot of like the three Higgses. That was how much on the deep dive I was into weak interaction. I was going through such like comically irrelevant for my level sources.
I mean, Higgses is a horrible way of saying it,
Higgses.
in my humble opinion. Similar to using sigma as an integral variable. Horrible. I'm doing it right now. We should execute those kind of people.
Yeah, we used to burn people at the stake for saying stuff like this.
We used to
Yeah.
kill people with hammer for saying stuff like that.
Exactly.
It was better times.
By the way, also another question. In Feynman diagrams, gluons are different from just the boson.
Mhm.
Why?
What do you mean? Like they differ from a normal boson?
Like they have
I
a
don't-
different notation from a normal boson. Where boson is just a wavy, by gluons are
Yeah,
loop
no,
loops.
that's just to show it's a gluon. Because they interact different. And so it's they show that it's like a gluon, so it makes your calculations easier. It makes it like from the Feynman diagram, you're supposed to immediately write down the corresponding equation, which is usually like a rate of the process happening. You're immediately supposed to write it down just from the Feynman diagram. So that's why they introduced these kind of different notations for different bosons.
That makes
Because-
sense.
Because the bosons, like mediating different interactions, also behave differently. As they should, because otherwise the interactions would be the same.
No, damn it, I cannot find it.
It's fine. Just go back to your Feynman diagrams.
Well,
I am.
not even at this point. I am really confused about weak interaction because
Yeah, me too.
I don't understand when it happens.
There's nothing to say about when it happens. It just happens.
It's just RNG. Roll a dice.
Yeah,
Flip a coin.
the whole thing about this is that they are random, and that's why with the weak interaction, we are usually calculating like interaction rates.
Wait, they are genuinely pure random.
Yeah.
Holy, oh my goodness! If you knew how much time I've spent trying to find what causes decay, like why? How can you flip an up quark into a down quark? Like not how, when? When does it flip?
Well, you can calculate exactly what probability it flips with.
Yeah,
I rolled
that makes
99,
sense.
so it flips.
But that is the amount of time I've spent looking for an answer of what causes it.
I suppose for the sake of the video, for simplicity, you can just say 50%. It either flips or it doesn't flip.
I mean, I'm not just gonna do percent. I'm just gonna do say random because the percentages don't really matter for the purposes of the video. It just
Yeah, because everything is just 50-50. Either it happens or it doesn't happen.
Exactly, he gets it.
or both happens and doesn't happen. Just stop giving
Yeah,
me
but-
Nah, 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 nah,
alcohol.
nah, nah, nah.
Then you get into the realm of physics, and physicists are fucking stupid.
Macaroni. Come on, that was so uncalled for. Just,
What do you mean?
You are sitting on a version with physicists.
And
Just say they're drunk. That's accurate. Don't say they're stupid.
no, physics is fucking stupid. Well, I mean, quantum physics is fucking stupid.
Even worse.
Yes, that clarifies a lot more.
Even worse.
I mean, physics isn't that stupid. You can build bridges with that. That's cool.
That's...
And cars.
You can even drive the cars on the bridges.
Cool.
Genius.
I like the.
But quantum physics, what do you even use it for?
I mean, you can build wells with physics.
Yeah, sure, buddy. But
Infinite,
quantum-
infinite potential wells.
I mean, you kind of need the quantum for phones and stuff. You're welcome.
Nah.
Yeah, but at the same time, you know, I feel like that could be the dark side of physics. Like physics gave us the internet. I think that's a negative.
And maybe that's why it's
Yeah.
stupid. I mean, to be fair, if we didn't have all this stuff, I wouldn't hear some random ass guy on the internet calling physics dumb. It's all because quantum mechanics.
Hold on, I have a picture for you, Remco. I have a picture for you, Remco, and that thing will convey the point.
I will await your picture.
Oh, there we go. The
Stop doing
Yes, I've
physics.
seen this. Statement streamed up by the utterly deranged.
This is real physics, but I like the fact that like this could have been so much worse. So much worse.
The last one is string theory.
No, the last one is the only one I don't know.
String theory.
That's probably why I don't know it.
Yeah, we're folding up the dimensions. So we can't see them. That's one way to explain more dimensions.
I do have to say though, the two graphs on the left, right, the Feynman and the orbital, both of these were specifically made because the calculations were so tedious that no one could even.
Uh-huh.
And in this case, they're like, look at this is real physics. This could have been so much worse.
Uh-huh.
Okay.
I agree.
Okay, so
They could be melons.
hold on. So let me get this correct, right? Imagine that we have a. All right, three fields. Just three fields, and we're gonna ignore the other ones, right? The other ones are implied. We have the up quark. We have the up quark, which look like this, right? Actually, hold on. Let me just. Then we're gonna have a down quark, which will look like this. Then we're gonna have the W boson field. Okay.
W.
And so this would be proton. All the fields are implied.
Yes.
Okay, now basic idea then is, if I understand it correctly, is that there's a random chance that one of the quarks, so for example this one, hold on, let me actually leave it here. There's basically a random chance that this quark will just turn into a down quark. Hold on, no, down quark. Like this. And a W boson, and the other fields are implied, so we'll leave the third one out. Like this.
Mhm.
Actually, no, it would turn just into a boson, wouldn't it? Because then the boson is the one that turns. No, wait, it would turn. Yes, the Feynman diagram. Yeah, because it would look like this. Right, with the up quark, down quark, W boson. Since charge goes from positive to negative, that would be positron, I think, and then
Positron?
neutrino. Am I getting this right?
I don't know the exact Feynman diagram, but it sounds cool.
But like
it looks cool.
it's this. But like
Let's
this,
just
right?
assume it's right.
But like this, the line, the fields
Yes.
are more important. So it would
Yes.
it just straight up has a random chance to turn into a W boson.
Yes.
Fucking brilliant! Why do I?
Wait, exactly like you plot it. Except then, like within a very short amount of time, this W boson needs to decay into the positron and neutrino.
Yeah, exactly. That's why. So, like in this case, as we have this would be like this slice of time happening, right?
Yes.
These are the two slices we have: the up quark and.
Yes.
I mean, sure. Yeah, why not? Might as well. I am so defeated right now.
See what I mean now?
Can someone tell me what the video he's working on about? Oh, Feynman diagrams. Ah, I respect that, Brickmaster. I respect recognizing. I mean,
see,
this is
if
like
you-
my problem with this is that I was expecting it to be so much more complicated.
No, I'm telling you, these things are easy.
Like this is genuinely, it's hard for me to describe just how much I've overestimated this. I mean, I do understand that as I keep going to advanced stuff, it would definitely get really difficult. But like this is deceptively simple.
The whole point about this is the diagrams are very easy, and that's why we use them. The equations you get from the diagrams are not so very easy.
I mean, yeah, exactly. Thank fucking goodness I can leave the equations out.
Yeah,
Is this
thank Feynman actually.
Is this the case of fundamental particles into other fundamental subatomic particles? It is the decay of fundamental particles into other fundamental particles. You cannot decay a fundamental particle into a subatomic as well, as far as I'm aware. Unless you include a fundamental into subatomic, which you shouldn't, because that's a crime.
Wait, but this process that you just described is proton into neutron, right?
Yes.
Decay. Yeah, we have not observed that yet.
What do you mean we haven't observed proton to neutron?
Decay? Not decay. I mean, we have described like adding energy and stuff, and then switching the quarks. But we have not observed the actual decay of a proton into a neutron.
Wait, when you
Because
say
it's-
that,
Yeah.
do you mean like we have it only theorized, or do you mean like we haven't specifically seen a proton decay, but we have seen the
No.
effects?
There's a lot of experiments just having like a whole bath of hydrogen, like just hydrogen, like hydrogen atoms, hydrogen, and we have not seen this decay. It's theorized, yes, but we didn't find it yet. And if one of those decay happened, we are sure that it's one of those decays. So it just hasn't happened yet. This is probably because this chance of like randomly happening is so incredibly low, and there's like estimations that the half time of that is like much larger than the age of the universe and blah blah blah. Because we got like a whole reservoir of like 10 to the power 22
Wait, hold on. So you can
hydrogen atoms.
So you can easily switch from a, because as far as I'm aware, neutron decay that happens, right? Neutron into a proton.
Yes.
So you mean to tell me that like neutrons decay into protons all the time, but protons have a really hard time decaying into neutrons?
Yeah.
Shouldn't we be running out of neutrons?
No, because the neutrons are only decaying when they're bound. When they're not bound. If they are bounding with protons, their energy is lower because a lot of it goes into bounding energy. So they don't have the available energy to decay anymore. This decay takes like 15 minutes if they're unbounded.
Okay,
Half-life.
hold on.
This saved us.
Doesn't that? But like that does mean that over time, we're just gonna run out of neutrons.
No,
What do you mean no?
Why?
If
because they don't decay when they're bounded. They don't have the energy to decay.
yeah, but like if a neutron gets unbound, right?
Oh, yeah.
That
I
but
suppose.
like what I mean is like over time, eventually, it's really unlikely for a neutron to decay, but it seems like for a proton it's borderline impossible.
Yeah.
That's brilliant.
I mean, to be fair, this whole process is what saved us in the beginning of time, because we had a lot of neutrons for some reason. Because that's, I think, the best configuration for quarks
I mean,
to like combine in the quantum soup. And then these neutrons started decaying because they were unbounded into protons, giving us hydrogen effectively because they were catching electrons. And at some point, these neutrons bounded with protons to create like higher order molecules, atoms, whatever. And that's what stopped this decay of neutrons. And if that didn't happen, this whole decay, if the lifetime of a neutron was like slightly larger, slightly smaller, then we would have had differences in like the hydrogen and helium power rates, like ratios, and life would have been fucked. So it's like, in a sense, you can consider the lifetime of a neutron a very chaotic parameter, where if you just slightly increase it or decrease it, like your entire universe turns out differently.
I see. That is.
So be very grateful.
I genuinely thought that proton decay happened.
Oh no, we theorized it. Surely.
I mean,
it
eventually
happens.
it's going to happen.
Fucked.
Eventually
I
it's
mean-
going to happen.
If the Saddle model is right, then yes, it's one of the predictions that we haven't confirmed yet.
So
But
comical.
if it doesn't happen, we're fucked.
Okay. So the next question then. Basically, the flavor, right? What is the flavor of a particle?
The flavor?
Yes.
It's if you want it in mathematical terms, it's an independent basis vector of the same particle representation.
Okay.
So there's like 3 different ways. No, wait, is that 3? Yeah, there's 3 different ways of building the same particle, and they are independent, so you can't like go from one to the other without some exterior operator.
And so weak interactions effectively switching the flavor.
I think so, yes. Do they?
Isn't the Z boson switching? Did I get that wrong?
It might. As I'm telling you, these bosons are horrible. I don't like them. I think they. I think they do. Yes. That they. Wait, they are matrix representations. Yeah, they swap sections. Yeah. I think they do, but I'm not too sure on that.
Hold on. Don't worry. I'm look at the manuscripts.
Because, for example, this case is a weak interaction, I think. And like it changes a down quark into an up quark or something, but it doesn't say anything about the flavor.
Right. Yes. That's.
Flavor?
Oh. Okay. Hold on. Particle flavor.
Why would you spell it in the American way? Please don't do that.
What do you mean?
Flavor needs a U. Yes, thank you.
I know, but when I look it up with a U, I don't get things because they all spell it without the U.
Well, you first write a U to get like the professional.
And then the amateurs.
Yeah.
But actually, hold on. I know this is a bit of a meta question, a bit different. But like, when it comes to the Feynman video, what do you have in mind for a general progression of how it would go?
I thought of like going through the Feynman rules, which is basically how to construct these Feynman diagrams and how to get the equations from the Feynman diagrams. So it will be a bit more involved. But it's a very like it's a set of rules that just always work, like without exceptions. So it's very it like if with those rules you can just make your own Feynman diagrams.
Make your own Feynman diagram at home. Remco
Yeah,
approved
do it
kit.
yourself. Feynman diagrams. Anyways, I thought about it for a second. Go back to the drawing where you were drawing the waves. Yes. So if the first up quark, like the left up quark,
Wait, left this one.
has yeah. If that one has color green, if the down quark has color red,
Yeah.
yes. Then and if the last one has color blue, then if the last one changes, it still needs to have color blue
Right.
because the other ones didn't change.
Yeah.
So in this particular interaction, the color is invariant, or the flavor is invariant. I don't know about other interactions though, because if you have like stuff where two, or like if you have gluons involved, then they definitely change colors. But I think those are only strong interactions. Yeah, I don't think they are weak. Hypothetical decay of photons. Keep in mind of protons. I mean,
Brickmaster just asked, are you graphing the wave function of the actual particles in the Feynman diagram?
I don't know what you mean with graphing the wave functions. Oh, no, we have, yeah. What we are, yeah, actually, yes, we are in the drawings graphing the wave functions of actual particles. Where, in this case, a wave package just represents a particle. But we are not doing that in the actual Feynman diagrams. That's just make it take. Which is a good one, I'll say.
It's even the same. I'm just drawing what the animations in the video will look like. I mean, you can see it. This is the white line. I mean, in this case, the white line represents the electron field. In the drawing, it represents up quarks.
It is maybe interesting to mention that at least for fermions, the electron field and the positron field are the same field.
Wait, so like for antiparticles of fermions are on the same field as particles?
Yes.
Okay. How?
So I don't want to see any electron field and a separate positron field.
I haven't gotten the antiparticles would be after all of the basic particles have been covered.
Yeah, okay.
Except for the Higgs. So wait.
And the photon.
How? I mean, no, photon will be covered. I specifically will mention the antiparticle of the photon, which is photon. But macaroni left.
Oh, we scared someone away. That's good.
But hold on. So, what is the difference between an electron and a positron then? I mean, I know that you get what I mean. You get what I mean. The question.
The wave package has properties such as the charge. It's a bit hard to visualize.
Right, okay, yeah, fine. That's a bit hard to visualize. It's gonna be in the video when I get to antiparticles, I'm gonna show two very similar wave packets, but be like, one of them is an electron, the other one is the exact opposite, and you just have to trust me on this.
What you could do actually is draw the wave package upside down. Instead of going up, you can. Oh wait, that doesn't work because you. Oh fuck.
I mean, I can.
It's symmetric
Exactly.
onto the line.
Like, I can just multiply it by a minus so that peaks are.
Yeah, but that's
reversed.
difficult to see.
That's what I'm saying, right? They'll be almost the same. But I mean,
what
it
you
would
could-
be nice because, like, when I move them closer in together, that could, actually, when I move them closer in together, that could look really good. Hold on, I'll show you in a second what it would look like. Just 3 more frames and then I'll show what it would look like, because I feel like that could actually, particle annihilation would look really good then.
What you could, is, for example, like the top of the the top of the wave package, you could make it green, and like the bottom red, and for the antiparticle it would be the other way around.
It's also maybe.
Like, because if you turn it around, it's difficult to see. But like, if you have the colors like opposite, then it will be more easy to see that one is an antiparticle. Or you will need to think about it.
No, hold on. I'll show you what my idea would be, because I feel like electron annihilation would look really, electron positron annihilation would look really, really nice in this.
Yeah, no, I know what you're going through. I just hope
Yeah,
you.
but I still want to see it. Okay, so it rendered. Now
Let's see if your code is properly coded.
740. Okay, so basically we're gonna have electron and then multiply by -1 positron, and we're gonna have positron at -2, electron at 2, like this. They are very different, as we all can see. They are very different.
This is indistinguishable.
But no, it's totally different. We all know that it's totally different. But then if we switch this to 0 and this to 0... Oh, yes! Hold on, let me just... Let's look at it.
I have
Positron,
one
electron.
Yes, I can see which one is which. Hey yo, it works! You
works
should
really
let it
well.
play for a second longer.
Right. I mean, there's gonna be nothing there.
Yeah, exactly, that's why. Yeah, this is exactly what you want. So it's just a straight line. And then you need the photons to do something in the photon realm.
This is a great... I've never seen it visualized this way on YouTube, and I don't understand why. This is... I don't need to toot my own horn here, but this is a brilliant way to represent particles.
This is why we have you. I mean, it's not entirely accurate, keep that in mind. There is some flaws with this.
Like, yeah, but obviously, you know, every representation that's meant to be like a visualization will always have flaws.
Yeah.
But I've just... You know how whenever anyone mentions relativity, I always say that I don't want to make a video about relativity because I have nothing new to bring to the table, because Minute Physics did such an amazing video on it. This is how I feel about...
Sure.
This is how I feel about this. I genuinely don't understand why no one's done it.
No, if I want to crush your teams a bit, I have seen this before, but
I haven't. Where have you seen it?
some tool where you can make this yourself. You have to use it for quantum mechanics.
Alright, I raise you the probability of finding electron and a positron in any given spot.
Don't you need to flip one? Well, you don't have to, but...
Well, you
It
want
will
me
be-
to multiply this one by minus.
Yes.
But I mean, shouldn't this represent probability?
Yeah, it's all negative, but it's nice for the visualization.
Negative probability.
You should also not do anything with the negative probability, other than just play. Don't calculate with it.
Alright, hold on, let me just reset it.
Like the same thing Brickmaster is saying.
So, antiparticle as the negative of the square. Would it... Wait, would that work? I feel like...
Not in physics.
Yeah, I mean, I feel like that
Yes,
would
in
be...
visualization, I think.
I feel like for the sake of visualization, that could go a bit too far with negative probability. Okay.
But yes, once yeah, exactly. We don't want negative probability.
Now with this electron in mind, let's add another one. So right here, what we're going to do is just add another electron.
you will need to think about the way to visualize the positron and electron, though, because that you will need to like a distinct visual difference between them. What you could do is like all the different
I can
fields
just
will have a
label
color,
them.
right?
I can just label them. I
No,
can just like.
boring.
No.
All the fields will have like a associated color, right?
Well, yes.
All right, play with the darkness.
But you want me? Oh, you want the electron to be bright and positron to be negatively bright.
Not bright in the sense of luminosity, but like mix some black with the color, or mix some white with the color.
No, I mean
Like the
I
colors
can.
themselves.
I can
should
literally
be...
have a non-fluctuating field be not bright at all, just emission value of 0. For the electron, it could have emission value of 1, and for the positron, it could have emission value of -1. So
See how it looks.
I think it's gonna look like shit, to be completely honest with you, because like you can have negative emission in Blender. It is not recommended. You can. How would I even apply shader to it?
Well, that's why I'm like, maybe don't do the luminosity or the way like the shadowing or whatever it's called. Just change the color of the field to something slightly darker. Like if you have usually you have like this slider.
Like we will be able to pull off these things. I mean, for quarks, for quarks on their own, I'm gonna color them red, green, blue, right? So like, all of these things will be representable. Gluons, I'm not going to bother coloring because I think genuinely colors make gluons even harder to understand than they already are. Because like, Wikipedia gluons.
Why do we always come back to color theory?
I mean, I can because there's the 8 equations. There we go. 8 color states. So like, I could just literally do this with vectors. Actually, I'm curious what it would look like. Let's try it.
Uh-oh.
No, because it would be really easy to make. I'm genuinely curious. I mean, okay, we do have imaginary numbers, but I still.
I mean, what you could do with gluons is always just like if you have a green quark and a blue quark, and you want to glue on between them, you can have the color like anti-green to anti-blue as a gradient, and then you need to think of what you're going to consider anti-blue and anti-green.
I mean, anti-blue, anti-green, that's easy.
Yeah, but, just the opposite colors, but yeah.
But the bigger question is that, like, these are the actual colors. Right? Like, if you have a gluon between a red quark and a blue quark, it's not really a red-blue gluon.
No, because it's a superposition, but once you like visualize it, it's not a superposition anymore because you choose a particular representation.
Are you right now advising me to not visualize superpositions? What has happened?
Actually, go for it. I am so curious how that will turn out.
That's what I'm. That's what
I'm faith in you.
All right, here's how we can do it. This will be our gluon for now. Gluon.
Yeah, the color charge is a misnomer. It's basically the same as in electromagnetism, where you have plus and minus charge, except now you have 3 different charges, and they also interact in more complicated ways, therefore. But calling them colors was a horrible idea, because it just confuses people.
Yeah, the same way you could ask a question, Brickmaster, you could ask a question like, what is electrical charge? Well, electrical charge is just charge, and that's it. There's no explanation for this. It's just like a fundamental property. How much video thumbnails became AI generated? I think it's but AI generated thumbnails themselves look horrific. Natural step in the progression of clickbait. I don't know what to tell you. Okay, right here we're gonna have the color, and here's what we're going to do. We are going to create
Brickmaster, are you specializing in physics?
Combine color. We're going to create 1, 2, 3.
I see. If you didn't, I was going to suggest you should, because you're asking very good questions. Exactly the type of questions physicists should ask.
That's high praise.
Yeah, this is a huge compliment. Take it.
It really is. You really should take it. All right, index switch, and we're gonna have index switch for color with 8 entries. 4, 5, 6, 7, 8. Okay, there we go. So right here, we'll be able to test all 8 possible color states for gluon. Now right here we have red, green, blue, then hue, saturation, value. Oh, can I not do... You are pissing me.
No, I don't think I am.
Well, someone is. Someone clearly is. Why can I not do color operation on this? Combine color... Ah, fine, whatever. Anti-red is just green, blue. Anti-green is just red, blue. Alright, so these are the 6 colors. Then the first one would be color mix color, right. I need to... Alright, vector math. Divide by math square root 2. And we... Okay, so the color is effectively multiply, this is not going to work, red but by anti-blue, and then blue by anti-red. No, this won't work. This will not work because this isn't multiplication. Like, this would be the first color. But the reason why it doesn't work is because this is effectively just anti-green. We'd need to somehow define the operation of color combinations, which we could do with mixed color, I guess.
They should get wide. Combining 3 types of color should give you wide. That is wide to me.
You're not wrong. I'm pretty certain it is perfect wide, actually, yeah.
Yeah, because you're probably having like a radio polar coordinates of the colors, and then the middle point is just wide. So combining 3,
Oh yeah, I am
like everything
adding
over
together.
3 of these colors, it will just give you the middle.
That is true. Yeah, because there's red, anti-red, blue, anti-blue.
Ah.
But that's precisely why we need to find some kind of operation for red anti-blue.
Why is it always color theory? That's keeping us back.
If I had a nickel,
You would be rich. Like,
I would be
just
so
based
rich.
on material value.
Wait, this could work actually. Darken this. Alright, this is half the battle. Because then
That's not even half the war. Because it's 1 over square root 2. That's your normalization factor. That's not half.
Shut up. It took me such a long time to process this.
It was such a good joke.
Okay, red, anti-green. Green, anti-red. So this is the second color. Then we have 2 left, but the last one needs to subtract. Okay. It might be negative brightness with the last one, but whatever. Blue. It's blue anti-green. Green anti-blue. This is color number 3. And then color number 4 is red anti-red. Blue anti-blue. This might be negative brightness. Ah! Haha! That's a good sign. Okay, what else? Then after all of these, we have... Oh, what would multiplying by negative I mean in this case?
Hmm.
Hold on, no, I have an
Oh.
idea, I have an idea. We can separate them off by hue saturation value, plug them in, but add a quarter to the hue. No, subtract the quarter from the hue.
I am trusting you.
You
I
shouldn't.
have lost like track ages ago.
Okay. So this will be yet another new group, and in this case we would have the entire debacle with subtract in the middle, but at the same time separate color, hue saturation value, combine color, hue saturation value, and then math. Subtract. Wait, no, subtract 1/2. No, subtract 0.25. Okay,
My equation is escaping.
your equation is escaping.
Yes, it's running off the page.
You need to go catch it.
I'm trying.
Anti-blue minus blue anti-red. I like how this one is red but has a yellow globe, which don't think about too hard. Okay, this is the next one. Then we have 1, 2 more. Which are red anti-green minus green anti-red, and then blue anti-green, green anti-blue. Okay. And then one last final color is in fact not multiplied by negative I, how convenient. Instead it's divided by square root of 6, and it has by 2. Okay. There we go. This is our last color, which goes red, anti-red, blue, anti-blue, then green, anti-green. Remco, I present to you. Are you ready to watch?
Purple?
Okay, are you watching right now?
Yes.
8 colors of gluons. 0, 1, 2, 3, 4, 5, 6, 7. That's the last one. There we go. 8 colors of gluons based on these equations. I told you it was possible.
You know what? I'm digging it. Now, what I do wish you I could a lot of luck with is making sure you have the right color for the glue.
Oh, I didn't think about that at all, actually. Shit. I love turning imaginary numbers because... No, actually that makes sense. The multiplication by imaginary makes sense because, like, if you imagine a color hue circle, right? Hue saturation value basically works this way. Imagine like a cylinder. Okay? Now, value goes from bottom to top and tends from black to white. saturation goes from middle outwards and turns the color into a more saturated color, and hue just rotates it. So in order to represent multiplication by negative I just rotated the color by quarter of the way. It makes sense, right?
Yeah, you're basically using that in polar coordinates. You can. Why are you actually turning it clockwise? Oh, that
Yeah, because
you just
negative I.
every mathematician turning around in his grave.
Well, wait, shouldn't negative I be turning it clockwise?
Oh yeah, you're right.
Yeah, exactly. There you go. The instant switch. But there we go. By the way,
No. You're not supposed to rotate it counterclockwise. You're supposed to rotate it 3 times counterclockwise. Yes, which is 3 times clockwise, counterclockwise.
so you want me to rotate it this way, and not
No,
this?
wait, do it. Yes, exactly. Way better than that.
Fine. Listen. Fine. On it, boss. On it. Right here. Instead of subtract, we're gonna do add 0.75. There we go. You're welcome. Fixed.
Love it. All right.
The colors
Everyone is happy
absolutely did not
again.
change. By the way, everyone watching may notice that this color is, for the lack of a better description, very violent, isn't it? It's hard to
Oh, I like
describe it, but it's like very. It's not purple, it's super purple. The reason why, and there's a couple colors out there, like the red one as well. This one kind of. The reason why is because these colors are not only shining bright with their color, they're also removing other colors, which is making them, because effectively I'm outputting a vector, which can be negative. But there we go, we've cracked gluons. Now what about this? Yeah, I got so carried away. Super violet, yeah.
Love it.
Ultra even. You have two elections,
No,
lovely.
lots of good luck with implementing those. Correctly. I will be checking every single gluon I see in the video.
Hold on, no, because I can. If I figure out the rules exactly, then the nice thing is I won't need to implement it. I can just like put it into geometry nodes. They will implement it for me. But still, quick question. Glenn-Mann matrices. The graphite states are linear independent, so independent of the state. No way to add any combination of these states to produce any others. So impossible to make them.
I have bad news for you.
Mm-hmm.
There's one more.
What do you mean?
Scroll a bit up. The one color stayed.
The singlet.
The
Well, that's
singlet
easy
stayed.
because I can do it like this is effectively borderline the same as this. I can just take this geometry node, flip 1 minus to a plus, not
fair.
multiply and divide by square root. This is easy.
I see.
The bigger question is when do these colors happen? I don't think Vulcan is willing to make super violent. Why would you use that model though, instead of just adding a third axis? One axis for hue, saturation, and brightness. I don't quite exactly know what you mean, the Brickmaster. Who's the cracked who came up with this? Physicists, obviously. Alright, but hold on. What's the color of a glue? I feel like in the video what I'm going to do is just gonna mention that I spent a solid half an hour making colors for all the gluons and representing them. Only to then realize that I cannot actually implement them in any way.
No, I think you can check out which gluon goes where. I'll be researching, don't worry.
I was asking about the cylinder model of color used, but I get now. Yes, HSV. Goes back around to the end of the standing color. Yeah, it's effectively like, switching from Cartesian coordinates to polar coordinates. HSV is just the polar coordinates module to the Cartesian red, green, blue. Why isn't there 9 glue on? Because physics, complex thing, you have no idea how difficult of a question that is to answer in a satisfactory way.
No, there is a ninth one. It's just in the single state.
Could I pull off an anti-sigma bond? Oh, wait a second. How would I... Oh, can I do an anti-bonding sigma bond with this? Oh, great father time. Can I? Let's try it. Okay, first things first. We want to bring them close together regardless. Something like negative 0.5 and 0.5. Maybe 75. Okay, so this is effectively the sigma bond. Now, quick question. How would anti-bonding work? Would it be like this? Wait, no.
But even his anti-bonding.
Oh my goodness, I am incredible! Oh, I am incredible! Oh, I am absolutely magnificent. Oh man, visualizing this will be hard. I mean, if we take the time, or rather inside these,
Complex thing, that's a good question. The answer is probably.
Okay, this one should be 0. This is sigma bond.
I mean, technically, the electron spin is a superposition, and excitation of this of the atom, so also of the superposition, usually leads to coherence, in which the superposition collapses to one spin. So in that sense, yes, it changes its spin because it's just a collapse of superposition. This requires believing that decoherence is a thing. Other than that, it's probably still the case that it changes its spin. But I don't see the right equation as to why. I don't think spin is conserved in that sense. Just make it show your findings.
Huh? What happened?
No, you show whatever you wanted to show.
Oh, whatever. I don't want to show anything. What do you mean?
Well, then think of something to show.
Feynman diagrams, eh?
Hey.
The weather's been crazy recently.
Uh-huh.
Hold on, I just realized I need to...
Yo. I have something to say.
That doing drugs is never okay. What do you have to say?
Well, actually, drugs helps with studying a lot. What I wanted to say is I have the system that I was showing you before. I was calculating some properties of this system. Turns out, usually in quantum mechanics, if you have a system and you take the limit of h bar going to 0, which is h bar being the whole quantum thing, it usually turns classical. So if you have a system and you set just h bar equal to 0, or in the limit h bar goes to 0, you obtain a classical system. For example, particle in a box or something, the wave function gets all these nodes. If you set h bar limit to 0, you get like a standing wave. What I just got is a similar thing. I got like a similar integral, except now instead of h bar, I have n, which is the number of fermions. So in my case, the more fermions that I add, the more classical the system becomes.
I mean, that also makes sense, doesn't it?
No, I don't like that.
No, because I mean, like, if you keep adding fermions eventually, you are gonna turn classical.
Why? Why does the quantum rule like gets fucked over? Like, why can't there not be quantum interactions anymore? Like, they can still act locally, but apparently that's not the case. I don't
like even locally. Oh, that is odd. That's really weird. Remco, what's your dream physics job?
Retirement. After having lived a long life of being a professor. Wait, complex thing. What do you mean? The number of a half spin electron. The number of the spin, or the number of the amount of electrons, or huh? Please elaborate. Oh, so yeah, you are talking about the spin.
Aren't you gonna show the anti-bonding sigma bond from wave function animation? Yeah, but I already did that. That's the... I mean, it's rendering right now. But anti-bonding is when you just shift the phase, which means you just need to... Well, in our case, we just need to add a little bit to the time.
Wait, so anti-bonding is the one thing you showed in the previous video?
Yeah, you know, it's when you have the sigma bond that... Hold on. Like, you know...
Yeah, this is too much chemistry for me, honestly.
Motherfucker, this is quantum fields. What do you mean it's too much chemistry for you?
It's in chemistry.
Okay, you seeing what I drawn right here, Remco?
Yeah, it's happy face. Never mind, it's
Yeah,
now
so like...
a dog's paw.
So like...
It's like a paw print.
Oh, don't start. Alright, so right here you have the s orbital, then you have the sigma orbital, and the anti-bonding sigma. Right? And the basic idea is that in hydrogen, for example, this is what the electrons look like on their own. This is what they are when they are bonded. And in helium, this is how they are anti-bonding, which is why helium cannot bond. Okay, are you with me so far? I feel like that meme of Markiplier, jingle, jingle, jingle. I don't know if you know that meme.
No, but I can imagine something.
Hold on.
Like, I don't...
Hold on.
What is this anti-bonding state?
Markiplier.
How do you describe this in terms of the wave function? Hello, Ash.
It's this meme. It's Markiplier explaining SCP Foundation. Like, the whole bit being that, you know, oh, pay attention, jingle, 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 oh, I said your favorite word. This is what I feel like right now, because, like, this on the left, your brain just doesn't accept, right? Now, imagine this, Remco. Imagine that you have a wave function of an electron, which, you know, just like a wave packet, right? When those two wave packets come together, they can either interfere constructively, right? Form just a larger wave packet, or they can their phase can be off, in which case they interfere destructively. And right here there will be like a little bit of flat and then another one. I'm not drawing it well, but this should be flat, right? Does that make sense?
Oh, I see. Yeah. Yeah.
And like this, the same thing. Explaining.
What happens to everything in between? Is that not valid as like a?
Oh, what you mean in between them? Like,
Oh, wait, a sigma bond or like anti-sigma bonding is like all the possible not constructive interference.
as far as I'm aware, yeah.
Yeah, but what like entirely destructive interference?
Well, entirely
To be fair, it would not be a bond then.
in order for them to be entirely destructive, they would have to overlap.
Yeah, is that a problem?
Well,
Oh, that is kind of a problem.
yeah, that is kind of a problem. Yeah. I really
Valid.
I really do feel like the Jingle Jingle multiplier meme, like explaining chemistry to Remco. You see, and then you have the orbitals. I mean, wave functions, Jingle Jingle. It's wave functions. It's not orbitals. And then they form a bond. I mean, they interact together. They don't form a bond. No, it's not. They interfere constructively.
Yes, that's what I wanted to hear.
Oh, that would also be such a comical video to make. Just translating chemistry for physicists. Tricking physicists into learning chemistry.
Horrible video, downvote.
But that would be pretty funny though.
Yes, it would get begrudgingly. It would kind of be funny.
Where like I basically explain all of the basics of chemistry, but after mentioning every single term, I'm like, no, I mean, and then just replace it with the physics word for the exact same thing. He's moving diagram it's from the part because right now he's explaining bonding and anti-bonding orbitals. The nice thing about this Brickmaster is that in this case I don't need to explain bonding and anti-bonding orbitals because they are such a simple and logical consequence of quantized fields. Like basically, I'm having a hard time even explaining, but once you explain to someone how acceleration and force works, then you don't need to explain to them what position is. I'm not sure how it ties into Feynman diagram because that's physicist's brain rot. I don't think it would tie into Feynman because Feynman is not about this sort of thing. Exactly. I'm pretty sure the spin is the fundamental property of an electron, so with change it wouldn't be an electron. You have options. Two of them. You could either have spin or you could have the other spin. Hold on, I got down. Whoop, there we go. Damn it, you know what? Because you're busy, Remco, I'm switching the third video that we're working on today to tricking physicists into learning chemistry.
The lovely part is you already have like all the animation tools.
Yeah,
like,
exactly.
you already
Like for this video,
videos.
I'm not going to do basically anything because I'm just gonna copy over everything else.
Brilliant.
Ah, okay, so first intro. Ah, damn it. Whenever I make a video about quantum, about chemistry and all of those gosh dang physicists
Pesky
always
physicist.
leave. Pesky gosh dang pesky physicists always leave. What am I
Wait.
supposed?
I thought you said gosh dang. Like a Porsche physicist.
I don't like how many videos I'm making as a shitpost nowadays because. Fuck it, I'm bored, let's do it. What am I supposed to do?
The ultimate motivation. Fuck it, I'm bored.
No, they would actually enjoy the topic if they didn't think of it as chemistry. If only there was a way to trick them into thinking it's physics.
I give you permission to shit talk us.
I don't consider this shit talking because there are like certain things you can say.
Light bulb.
Yeah, like a light bulb, you know. But I don't consider it shit talking simply because there are certain things you can say about different fields of study, which to any other field of study would be an insult, but in those cases are just appropriate. Like if I, for example, say that Ash absolutely deals with nothing practical and will never deal with anything that could be used in a practical way, like that wouldn't be an insult. That could be an insult to a chemist, but to a mathematician, that's not an insult. That's just like the whole point. If you want to do something practical, go study physics. This is maths. We ball in this motherfucker. Okay. Orbitals. So first, let's start with orbitals. And I mean, wave functions. Yes, wave functions.
Wait, if you want more topics that like I don't understand from like the first contact with them, I can give you some more.
Okay, well, all right, give me a list and I see, because I may not be able to explain most of them because I'm not, I'm not all knowing after all. So, all right.
Like something like the shells, the 1s, 1p, 1 whatever the fuck they do. I have no clue. Like I had this in quantum mechanics like for one lecture and that's it. I have never seen it more than that one time.
Wave function, there we go. Alright, so that's one. I'm gonna do, by the way, it's comical in my opinion, but I genuinely believe that if you do chemistry in one dimension, it's physics, and if you do physics in 3 dimensions, it's chemistry. When you deal with wave functions. Because, like, if you would have seen the papers that Flame was citing in his when I was working the video with him, most of them were physics. Most of them were just straight up physics, because that had to be the source. Okay, so orbitals, right? Wave function. I mean, particles. Yeah, obviously we can't talk about specifically electrons. It's always just it's a particle. Okay. So we have these particles, and what are those particles? Well, obviously, excitations in their fields. Right. So we know. Just, okay, well, but hold on, because I worry that I may actually run out of topics. Could I do?
Just say some chemistry terms and I will tell you if they're clear or not.
I mean, okay, hybridization is another easy one. Because basically like any hybrid orbital. Any hybrid orbital is a brilliant one because hybrid orbital is effectively just a combination of electrons. That's it.
Yeah.
A hybrid orbital effectively translates to like a hybrid wave function, of a wave function that is based on more than on 2 electrons. So, well, it doesn't matter. You get what I mean.
Mm-hmm.
Like fluorescence would be nice, but that would be.
No, actually, I think that is the one thing that makes sense.
Yeah, that's the problem. That's too much.
Other
physics.
than that, we don't use the term fluorescence for it.
But that would be kind of funny to talk about fluorescence and then just replace all the terms. Hold on, let me see if I can hit up Flame.
Ooh, I see what you mean. Yes, that actually works.
Where like Hey, flame. Hold on. Which, but,
You know what, you
okay,
could do
before
the-
going first, let's plan this.
You could do the chemistry, Feynman diagrams, whatever. The carbon something lines.
The skeletal structure. Chemistry skeletal diagrams.
Yeah, those.
The chemistry Feynman diagrams.
Yeah.
Oh, that's fucking hilarious. Holy shit, they like. You know what? I kind of want to do. I kind of want to say something. It would be way more of a joke than me being genuine, but like I would say something like, okay, so in relativity, time isn't really different from space all that much. So like technically, you could think of just space-time, any one of them, just 4 directions of space-time. With that in mind, let's look at Feynman diagrams and then just show a skeletal structure with like. Because effectively, right here, you do have a right-going position, outgoing position. If Feynman diagram was just 2 positions, then it would be just skeletal structure. Oh, this is the most idiotic video I've done in such a
I'm
long
telling you.
Oh, that is... I do want to do that. Okay.
You can definitely relate those structures to Feynman diagrams.
Yes, I'm going to say that, you know, oh, in relativity, time and space practically are the same thing. So, you know, why do you need a Feynman diagram with time and space? Why not just 2 dimensions? Who knows what they are? And there's just space and
Yes.
space kind of like, alright, Feynman...
I love how oblivious this is of the fact that in quantum field theory we don't have this thing where time
Exactly,
and
that's
space are the
precisely
same.
the point. Like, yeah, exactly what I said, right? Feynman diagrams wouldn't make any fucking sense with space and space. What is that even supposed to mean? Feynman diagrams
I'm
across...
sure there's some diagrams which actually represent spatial dimensions only.
But like, in order for... Unless I'm wrong, I could be wrong, but like, isn't it the case that in order for Feynman, like the vertices on Feynman diagrams are the really important bits? So the places where...
Yeah, they're propagators.
Yeah, exactly. Like how can you have propagator without time?
You don't know what we're capable of.
You know what? Fair point. I can
But
see
you
why...
know, if there are any, they would not represent the same type of Feynman diagrams.
All right, everyone, we're brainstorming. What other shitpostness can we add? I know one. Sexual benzene and shit. That's basically superposition of all possible orientations. 3 double bonds. That is correct. Yes, that is correct. Before Feynman diagrams. Actually, no. Right here, resonance.
Ooh.
Resonance is effectively superposition. Well, I mean, okay, it's very not. It is chemistry version. Okay, let me explain to you how idiotic this is, because I really need you to understand. I really need you to understand this, Remco. In benzene, we represent benzene most often like this. There's alternative notation, but this is the most common one, right?
Is that the circles?
Yeah,
those things.
there is another one with the circle in the middle, but this is like the most common one. And
No, this is what I meant with circle.
yeah, so this is...
Hexagon,
So
whatever.
do you know why we represent it this way?
No? Well, probably because we have the double bonds on the...
Great guess, actually. Basically, a single line means a bond, a double line means a double bond. However, there is a problem with benzene, which is that benzene is actually like symmetrical on, so all of these are identical. So the question arises, where are the double bonds? In the ye olden days, because like you can count electrons and you can realize that you need to have 2 bonds, right? So in the ye olden days, we just thought that it was oscillating. You had 2 bonds, 1 bond, 2 bonds, 1 bond, 2 bonds, 1 bond. But then we actually realized that what actually happens in benzene is the conjugated pi system, which I have on the thumbnail of my most recent chemistry video.
Oh, that's what that means.
Yeah, so you have like a ring at the top. On the very left, the green one. And so effectively what this notation is come to mean is that Actually, I'm not quite certain if resonance applies in this case, but I know it exists in chemistry where instead of saying that when you have like a double bond and a single bond, when you count bonds, it makes sense for there to be a double bond and a single bond. However, in reality, atoms cannot pick which bond is double, which bond is single. So you end up with resonance where like both of them are double and both of them are single. Chemical superposition. Hold on. Wikipedia bond
What?
resonance. Yeah.
That makes no sense. It kind of makes sense, but like it doesn't make sense.
Now you know
Why is
what
this a thing?
chemists feel. There we go. Resonance is mesmerism. It's a way of describing bonding cell molecules by a combination of several contributing. Read this and tell me this is not superposition. By combination of several contributing structures.
Yeah,
Into
no, that
resonance
is
hub- That's
superposition.
superposition. Resonance hub is the accurate structure of the. Yeah, alright, that's an excellent. Great, Ash. That's brilliant. Is this a superposition of electron orbital shapes? No, superposition of electron orbital shapes is just hybridization, which is just like hybrid orbitals, which would be right here, combinations of wave functions, hybrid orbitals. But then we would also have superposition, resonance, flame. Hold on, flame. I am making a shitpost video about tricking physicists into learning. Physicists into. I did misspell it, by the way. I like that you know me so well, Remco, because I did absolutely misspell it. Into learning chemistry. And so basically the whole premise will be that I will explain basic chem things as if I was explaining physics. This is the list so far. Do you have any other ideas for what I could add?
Brilliant idea, by the way.
Oh, thank you. It's so dumb. Where did this even? Oh yeah, jingle. That's such an incredible blow up of an idea.
Maybe you should try to recreate the meme in the.
I'm going to, yeah.
If you're like having a section with filming, like, hey, get your attention back here
That
to
would
the
actually
physics.
that would be like a great callback at the end of the video. So you see. First, we have the wave orbital. Jingle. No, they're wave functions, right? Wave functions are orbitals and jingle. You could probably do something with electricity because electrons are quantum, also chemistry. Solid state chemistry does involve the kind of overwhelming hybridization, but unfortunately the larger you go, the less quantum things become, so that could be difficult. Probably.
Well, you should definitely say something about valence.
Valence.
Even though I believe that's just the outer layer. Well, you could do it in orbitals, I think. It's just the outer layer of the electron, right?
Yeah, the outermost electron. The electron that's like the furthest away from the middle.
Oh, in that case, it's boring.
Yeah. We need to look for...
You can... Bonds as interactions.
Bonds, that also could be tricky. That's because with bonds, like, you know, bonds hold together because of particles that are on the same field. So it's not really...
Super pairs. That's superconductivity. We are very well versed in that.
Yeah, in this case, when Remco says we, that's not even just me and you. That's just like...
No, that's physicists.
That's the entire science community. Hey, fun fact everyone, did you all know that we still don't have a widely accepted model of what makes superconductivity work? The more
we have like a couple of fading ones.
We have a lot of fading ones. We don't... I just always consider it hilarious that we like know that superconductivity is a thing. And we have seen it, we can make it, but we have no idea why it works.
Actually, that's not true. Like one of the recent models I saw in my quantum, not in my quantum, in my superconductivity course before I dropped it, they were actually explaining superconductivity very well.
Oh damn, egg on my face. Why is someone banging at my ceiling?
Bang back.
I'm just gonna walk up over there with a knife.
Why a knife? Take something. You were making a flamethrower, right?
Oh no, I'm gonna take Mike. Mike is the knife I have with googly eyes on it. I can promise you that there isn't a threat to someone you can make on the planet that is as terrifying as someone calmly talking to you whilst holding a hunting knife with googly eyes on it. When you you just don't want to engage just in case. Hi, the caper. How you doing? Isn't superconductivity what happens when things get recalled? Yes, it is.
But not always.
Not all the things. All right, hold on. So first we have this. Obviously, accelerated field. Right. So we know it's just waves, and from these waves, you can square them, and there we go. You get the probability of finding the particle. Splendid. Now, these wave functions are based on different numbers. The quantum numbers. And as such, as we change those numbers around, the wave function could get larger, smaller, more wavy, have different orientations, the whole shebang.
Apparently, electronic structure is just the quantum state of electrons. What the fuck?
Figure out the OR thing out, and if you're implementing it, oh, that's neat. The fact that I understand all these things is equally fun as it's scary. I mean, everything I'm noting down so here right now, it's very basic chemistry with very in-depth physics. I wouldn't say advanced physics, but like, it's physics, certainly. How about you, Mr. Makinman? I am just losing it, apparently, is what's happening based on the stream so far. Oh, by the way, I should have been rendering this. Why was I not rendering? Why I'm wasting time. Why was I not rendering? Okay. Right here, what we need is we need to offset the phase 0.5.
You should definitely do something about the anti-bonding.
I mean, anti-bonding is just when... That's going to be just the hybrid orbitals, because effectively, like, every single hybrid orbital in existence, so that comes with bonding, anti-bonding, solid state, metallic bonding, it comes from hybridization, benzene, conjugated pi system, all of these are effectively the same way to combine wave functions.
Yes, so it's just either constructive, which interference, which gives you bonding, and destructive interference, which gives you anti-bonding.
Yes, you either get constructive, which gives you a lower energy wave function, or you get destructive, which gives you higher energy. And the lower energy means bonding because it's lower energy, and the higher energy means anti-bonding because it's higher energy. It's also like how virtual particles randomly pop up in the vacuum, holes and electrons also pop randomly in pairs, so we can maybe pull something there.
Semiconductors are really famous in physics. Like, we have some solid state courses that are mandatory.
I think what else could there be? I could go with like the probability of a transition state going to either product or the reactant. And I could have that as just general probability in physics. I could have that as a decay. Oh, that would be idiotic. So basically, as you go from, let's say that we have reactants. I always go for oxygen and hydrogen example.
You have to explain reactants first.
Yeah, no. So imagine it this way, right? Like, you have oxygen gas, you have hydrogen gas, and you have another hydrogen gas, right? Actually, well, I messed it up a bit because they should be high in energy. This would be certainly one of the biggest stretches, and it wouldn't work quite as well. But I kind of like how idiotic it would be. So, like, hydro represents energy, right? So imagine it this way. Then in the middle right here, you would have like something weird looking. So something like this, where it's just all like a single molecule, right? And then on the right, you would just have water. And the whole point here is that water is lower in energy than both of them. And the way that a typical chemical reaction works is that you take your reactants and you take them into the transition state. And from the transition state, they can either fall back to being reactants, or they can fall back to being, product. And so the whole bit there being is that when you give energy into a chemical reaction, then this kind of keeps going. So basically, if you have hydrogen and oxygen gas, if you set it on fire, you give it enough energy to reach the transition state. And then once it's burning, it's sustaining itself. So it's kicking all of these back up there, and over time turning into water. And like,
yeah.
And like, you know, having an up quark go into a W boson, go into a down quark. That could be. So explaining this in terms of decay would be so funny.
I see quantum tunneling here.
Holy shit, the melon! Holy shit, the propagator! No, this would be holy shit! Okay, no, this is great. Okay, so basically, imagine that you have, you start with a down quark, right, Remco? And you end up with an up quark. How did this happen? Well, and correct me in this case if I'm wrong or inaccurate, because I believe I will be inaccurate, but I do believe that the underlying idea will be correct. What could have happened is, I'm just gonna do D for down quark, U for up quark, and W for the boson, and I'm gonna ignore all the other particles for the sake of simplicity. What could have happened is the down quark could have decayed into a W boson, which could have decayed into an up quark. Actually, no, quarks are an idiotic example. Let me go with photons. Let's go with electron. Holy shit, what is something... Let's go electron, and photon in between them, because that would be easier. So you start with an electron, you end with an electron, right?
Mm-hmm.
I know I'm not, but I'm making up this thought as I go, so that's what it's taking. Now, how could this have ended up? It could have been electron into electron, or it could have been electron into photon into electron, right?
Other than that, this is an illegal process, yeah.
Because it should have been electron plus positron into photon, right?
It should be 2 photons.
Electron plus positron into 2 photons, that's correct. Okay, so...
Wait.
So imagine this, right? This could have been this, or it could have been... why am I doing it like this way? I could just do it using proper notation. This, or it could have been... they go side to side. Have to be 2 lines, wouldn't it? I'm certain that you know what point where I'm trying to go here, but I am just struggling because I really want to tie it in. The point is, if you start with a propagator, if you end with a propagator, then there is basically an infinite amount of ways you could have reached that propagator.
Ah, yes.
Right. So electron positron. You could have electron-positron directly into electron-positron, or you could have had electron-positron annihilate each other, create photons. Photons create back electron-positron, and you end up with electron-positron.
Yes. The infinite amount of contributions to the
The
complicator.
same way, if you start with oxygen, hydrogen, gas, and you end up with water, what could have happened is you start with the reactants, they turn into a transition state, they turn into the product. Or you start with the reactants, they turn into the transition state, they turn into reactants, they turn into transition state, they turn into the product. Or you start the reactants, they turn into the transition state, they turn into the reactants, they turn into the transition state, they turn into the reactants, they turn into the transition state, they turn into a product. And effectively, ... it can really go on ad infinitum forever. And even more, if I remember from explanation, each one addition becomes less and less likely. Right? Each time you add in another step in quantum mechanics to the whole electron-positron annihilation.
I see what you're trying to say. It's a far reach, though.
In this case, each time you add this in, you also decrease in probability that that's how you ended up with the product, simply because this is less likely. This is less likely than this. Hi, Dekatsi. How you doing? I know it's a fire reach, but it's funny. Listen, if we're allowing Feynman diagrams as the skeletal structure, then by golly, I'm allowing this.
Yeah, but you need Feynman diagrams to show whatever you're trying to show.
I know, it'll be fine. I'll figure it out. And then propagators, which will be transition state reactions. You know what? If I could actually end up with this video being done either today or tomorrow if I'm gonna lose my mind enough. No, that's good. This is really good.
You should upload this video after the first video where you also treat Feynman diagrams. But, like the video you're working on with the wave packages.
I'll do it after, but the wave packages video is gonna take a really long time.
But like this point is very difficult, and the Feynman diagrams is also very difficult to.
I mean, no,
show.
Feynman diagrams, like on a basic level, are quite easy to understand. It's just that
but you will need to
using
explain them then.
Using them is difficult. And let's be real, in this case, this video won't be all really educational, will it? It is very much.
That's fair.
Patience, the whole shit.
There must be more things.
Hey, there must be, right? Like, there's no way there's just 5. I mean, the fact that we end up with 5 is already incredible.
No, I don't. I think there's way more. Like every field of physics or mathematics just changes their notation and wording.
And now, as we have those different wave functions, some of them will have different energies. Pauli exclusion principle, could that be different from a physics perspective and a chemistry perspective?
It depends on what the chemistry perspective would be.
Chemistry perspective is just that 2 electrons cannot have the same quantum numbers in the same spot. So 2 electrons cannot be on the same orbital. More than 2, sorry, because 2 can be, because they could have opposite spin. How do fundamental particles decay into each other if they're fundamental? That's because decay is a bit of a misnomer in comparison to how we normally use it. When we think of decay, we think of it as going down, as in something decaying into something that's lower on the scale. But when it comes to fundamental particles, they just decay into each other. So decay, when it comes to fundamental particles, you should think of decay as just them switching between each other. Because I get what you mean. Like, for example, if you have an atom, then when atom decays, it doesn't turn into another atom. Only it like either emits an atomic particle, a subatomic particle, or an elementary particle. It goes lower. My point being, but when it comes to fundamental particles, they just switch. Okay. Oh no, wait, I'm an idiot. I shouldn't have. Oh, damn it! I shouldn't have rendered that. That's because right here what we need is just the loop. Jingle, jingle, jingle.
I love it so much.
That's such a dumb meme. But I mean it. where is I mean particles. Excitations in the fields, right? Wait. Different based on different numbers. Have different energies. Okay, so this is effectively quantum numbers, how they affect. How the quantum numbers affect the energies of a wave function. Actually, let me have a look at the quantum numbers if I can find something. Quantum numbers. Ja, danke, Book History. Hast du chemical? Oh, who's a good quantum number? Who's a good quantum number?
Damn.
I'm losing my mind, Remco. I'm not doing well.
I can tell. Keep a grip to reality. Don't let the darkness take you. Unless you don't like photons, in which case definitely let it take you.
No, don't go to the light. Don't go to the light.
Light is a hoax by the government. All the particles are to control us. This is why we vote for dark matter to be our government. Dark matter and dark energy is the way. I'm not in a cult or anything.
As is the different wave functions, some of them have different energies. So, be higher energy than this. Simple, right? Now, what? Actually, Remco, when you were studying physics, how did you view as a physicist switch from one dimension to 3 dimensions?
Oh, that was never explained. You just do it. But
Yeah,
like the
I
whole
know, I
switches, you
wasn't-
go from scalar to vector.
Yeah, no. I know, like, I know that, but like from your perspective, as you were learning physics, how'd you take it?
I accepted it as true.
Because I'm having trouble. Basically, what I need to do right now is in the video, I need to switch from 1 dimensions to 3 dimensions, but I want to do it in a way that would mirror the way it's done in physics the most, without just going into obtuse. So just effectively scale it to vector, and that's it. Or 1D vector to 3D vector.
At least in like the very early physics, like classical physics, where you have like this whole system, like the, for example, a ball rolling down on a 1D.
Yeah, okay, so there's...
Not rolling down, like there's a force on it. This force is just a scalar, it's just a number. And then once you start to like get a slope or something, this turns into a vector. And the only thing that changes is that instead of like the force you write it down bold now, because it's a vector.
3D. I mean, just use a higher dimension vector. I mean, that's
Just write a little arrow above your variables.
above variables. It's simple, and in this case, I'm just gonna have like P on the screen, and then there's gonna be arrow above the P.
Yeah, and sometimes you just get the random cosine out of nowhere.
We don't talk about that. Rotation. Oh, I'm so glad that 3 dimensions are exactly the same as 1 dimension. What do you mean rotation? What? Since when is that a thing?
Rotation, huh?
I think all vectors are 1D. Complex thing. I don't know what to tell you, but like, even easier.
It's a very bold way to say so when your entire name is a two-dimensional vector in real space.
I think all vectors are 1D. It's just like XY. Unless you mean.
You forgot about dimensions? To be fair, that is solid. We also do that in physics.
Just write an arrow of a variable. It's simple. With that in mind, I can just take our one-dimensional wave that is the electron and just expand it into 3 dimensions. There. This is the exact same function, wave function, but this time I could then do the same thing with like tricking mathematicians into learning physics.
You know what? That is also not a bad idea, but we need way more research for that.
That would be a lot more tricky.
Yeah, because mathematicians are so
Or
strict and such.
actually, it could be easier because if you just like replace references to things we have in real life, then that's already good enough. If instead of saying particle, you say, what would you say instead of particle? Instead of particle, that would be like one of the mathematical structures.
No, a particle. Well, it depends. If you wanted, you could just consider it like a singleton in a space.
I mean,
in a vector space.
It feels cheesy, but you could call it a set.
Yeah, no, that's exactly what I mean with singleton. A singleton is just a set with one element.
Vectors are 1D in the sense that the span of a vector is a 1D subspace of whatever vector space you're in, provided it's not a zero vector. Mods, kill him. Kill Ash right now.
No, he's right.
Don't ban him, kill him.
No. This is what we need in quantum. If this thing wasn't a thing, then we could not talk about phases and such.
Hold on, I need to get one thing real quick. I'll be right back. Shucks. I am back.
I have an amazing idea.
What's your idea?
Well, if we have like a chemistry to physics, and if we have a physics to mathematicians, we immediately get like a bijection from chemistry to mathematics.
Yeah, explaining chemistry to mathematics, that would be even. Well, I have another idea, which would be like tricking philosophers into learning mathematics, and it would just be like a 20-minute long, uninterrupted video of just me silently staring into the camera.
What?
Like dim lighting, you know, off atmosphere, some like dissonant chords playing in the background.
No, you need to sometimes say some words like
No. Silent staring, like with you know some in the background, something like. Hold on.
I see, I see.
Like 20 minutes of this.
I'm not sure if that will catch a lot of views, honestly.
I don't care, it would work. The series must continue. It's the same wave function.
Wait, what you could do if you do the chemistry to mathematics thing is you could talk about like orbitals. I mean wave function. I mean 3 to
Tricking mathematicians into studying medicine. just 8 orders of separation going down and down like. Yeah, you know, we have this organ. I mean, tissue. I mean, cells. I mean, proteins. I mean, molecules. I mean, wave functions. I mean, the most idiotic.
that can keep going.
Just keep going down though. Trying to wither with philosophers of the internet to get land maps. Exactly. Yes, that is the plan. Okay, simple. Now.
I mean, not like philosophers have time to watch these kind of videos when they're busy staring into a mirror, but sure.
I don't think they're busy staring into a mirror. I think they are busy obnoxiously just sitting on a park bench and looking down at everyone else.
To be fair, I am giving, like, I'm helping with a minor, I'm TAing, and this minor is for people who don't do physics and then, like, normal life, they just are interested in physics. And some of the lectures, we have an actual philosopher that is like lecturing about like why physics, how physics, whatever philosophy is behind physics.
What are they talking about?
Well, philosopher, it's I don't know if I can view them as a person. It's they give off such a weird vibe.
Like a wave function. Wait, would the principal quantum number still be considered some quantum number in physics? Would it still be called principal quantum number? Or Azimuthal quantum number?
No, we would call them energy eigenvalues.
Energy eigenvalues. Alright. But then I need to find out how to specifically say it then.
It depends if the principal number is the energy number.
I mean, the easiest one would...
It depends if this is related to energy. Yeah, the energy level.
Azimuthal.
So it would just be eigenvalues of energy.
Okay,
Hamiltonian.
Azimuthal describes the structure and gives the magnitude of the orbital angular momentum.
Yeah, eigenvalues of the angular momentum.
Eigenvalues of the angular momentum, alright.
Eigenvalues of the angular momentum operator.
Eigenvalues.
Even though, is that even the angular momentum operator? Because you have the square one.
Entropy of an always increases over time. When there are no isolated systems in the universe. I think. Oh, that's wild. Hold on, because there's another question. It's addressed to you, Remco. Is a curved vector real? And now, here once again, we reach the annoying bit where like, do they mean like, is it real or complex, or do they mean like, is it real or non-existent?
No, the whole concept of curved vector is like saying, I don't know, black snow. It doesn't make sense. Like, what do you mean curved? The vector is basically a point in a vector space, and the whole arrow we draw to it is a representation of it. It's just make it easier for us to comprehend what this point is.
Then why do you put arrows above P?
That is just to distinguish them from scalars.
This is even worse for me, Remco, because like in computer science, vectors is multiple values. It's not even a point in vector space. You don't have a space. Well, you do have a space. You don't think of it as space.
Yeah. Well, in physics, we also don't think of vectors as in a space usually. Like, they're just things. that move, that have like a direction.
No, in computer science you don't have direction, you just have numbers. That's it.
Number.
Numbers.
Wait. So a curved vector space, the closest thing I could get to is like when you're going through manifolds and you need to define your vectors as some sort of relation or how they behave under certain transformations, then you could technically have a sense of a curved vector. And yes, it could be real valued.
Yeah.
Wait, and Dark, why does the second thermodynamic law say entropy of an isolated system always increase over time when there are no isolated systems in the universe, and the universe is an isolated system? That is not proven. The universe could very well be a non-isolated system, and it's actually a very curious thing if it is not isolated. In which case, energy could either leak into the universe or leak out. Very funny thing. But in the terms of thermodynamics, you can just approximate your system as isolated. Like, it helps with the calculations.
Wait, hold on. So would the principal quantum number in this case be the eigenvalue of the energy operator?
Yeah, and what is the energy operator?
Hamiltonian?
Yes, look at you.
Wow, I listen. Of
Who knows?
Hamiltonian operator. What? I feel like a 5-year-old with you just hanging my picture on the fridge.
Hamiltonian operator is twofold. Hamiltonian is always an operator.
Yeah, but you know what? Fair. But I'm gonna do the angular momentum operator for the SMFU.
Yeah, but it will be the squared angular momentum, the square of the magnitude of the angular momentum operator, because you're talking about L squared.
Yeah, I know. In this case, it is the magnitude of the O2 angular momentum. That's
The eigenvalue of the magnitude of the angular momentum operator. Don't say orbital. Orbital doesn't make sense. They can definitely not be orbital. It's only for hydrogen when they're orbital. Fuck. Whoever wrote this is horrible at writing. And you also have the magnetic, right? The magnetic.
yeah, the magnetic and yeah. Also, I just found out the zero flow of thermodynamics isn't named after someone named Zero. That's a brilliant comment, and I'm adding it to best comments.
I love it. It deserves to be.
Allmatter also did a new GIF. I wanna hate it so badly, but I mean,
It's amazing.
Then we have the different electrons on the subshells, and like 5. No, wait. This will be the shell, right? So then the subshells, and oh, did I say electrons on the subshells?
Uh-oh.
The subshells, hold on, differentiated by the azimuthal quantum number. And oh, did I say electrons on the subshells? I meant particles with different eigenvalues of the magnitude magnitude angular momentum operator or magnitude of the angular momentum operator?
Off.
Alright, magnitude of the angular momentum operator is what I meant to say. Hold on. found out there's no physicist called First and Second. Lies. John First. One of my favorite people is John Law, inventor of the law system.
Yes, my favorite.
John Law. There we go. Where's the John Law? Hold on. Science, economist. There we go. It's John Law. He invented the law system.
Man, it's crazy.
Yes, John Law.
I hate that.
If you ever got like, oh, I'm glad the system of law exists, then you have John Law to thank for. It's John Law.
Now the question is this actually a system of law, or is
No, it's
is it
economics. It's economic system.
Horrible.
But it's great though. John Law is brilliant. All right, is what I meant to say. Now we can divide them further by their angular momentum and spin. Moment, spin, and all of these orbitals to look different. I mean, shit, wave functions. And then that's gonna be the entire first chapter. Day 30. Welcome back, generic person. How you doing? Oh, combination of wave functions. Yes. Next, we can combine these orbitals. And in this case, I'm just gonna do like a verbatim, like what we did right here, where I'm gonna do the graph of like two s orbitals coming together to constructively create the sigma bonding orbital and anti-bonding sigma, and then I'm just gonna be like, oh no, oh wait, no, this is a physics video, right? And then I'm just gonna do the exact same thing, except the graphics of the sigma orbitals will be different, where they will just be like waves.
You know what? That is amazing.
This entire video is brilliant, and it
makes sense as well. It's educational.
It is actually. I mean, it's more like a hook for other videos, because in this case, I will be going over everything a bit too quick in order for it to be educational enough. But like,
yeah, fair.
But I hope that it will actually convince some physics people in my community to actually go into chemistry as well.
Why are you trying to recruit people away from us?
No, but the whole point, like, it's not recruiting away, right? The whole point is that I've been saying for such a long time, the line between chemistry and physics is so goddamn arbitrary.
Yes, you are basically bridging the gap or tunneling the hill of which the language barrier.
I'm quantum tunneling between the barrier of chemistry and physics. Hold on. In the meantime, so to keep the stream a bit longer, if you don't mind, I'm gonna show some. Hi, Katsi. Yes, I know.
I've returned.
This reminds me of, there was a meme I recently saw on YouTube. After I woke up, where it was like, my entire YouTube page is filled with just cats. That's what it's filled with. It's I do believe that I had a friend who had a saying, which is life is like a rotten bag of chips. It was better in 2004, and basically, and back then the intro was just cats. It was great. So my entire YouTube page was just cats. And recently I saw a meme where like it said
entire YouTube page. We don't talk about the other half of the YouTube page, do we?
Yeah, but like recently I saw a meme which said like every single time my cat meows, I say I know, but I'm lying. I don't actually know. And I just realized that this has genuinely been my response to both when I had my cat, rest in peace, and like to Katsi meowing. I just say I know.
And when you had your awesome boyfriend, Katsi. I mean, girlfriend. Fuck.
So, so-
You know what? This is an appropriate time for me to go get some breakfast.
oh no, damn it! You spooked the physicist, Katsi!
I've been planning to get breakfast for like 2.5 hours, and yet I'm still here.
I mean, listen, I get it. I am right now in the background. I am just cooking myself some veggies. That's why I'm walking like that. Make it barely seems in my time zone, so I just woke up. Well, I'm still glad you could join. All right.
How math becomes difficult. Don't worry, we will soon have a video on how physics becomes difficult if we're going through with the Feynman diagrams.
It's so deceptively simple though, because I always thought of Feynman diagrams as a huge saver in making physics much more easy to understand.
Oh, I was specifically referring to the idea of going over the
using
Feynman diagram with the
diagrams.
rules.
Oh, using Feynman diagrams? Yeah, no
Yeah,
one
using
does
them
that.
is easy.
No one does that. No one uses Feynman diagrams. The I love Feynman diagrams people when they actually have to read them.
You translate them to equations, as to say.
Exactly.
We're going to do a video about that. Make it
I know.
has to.
Listen, I know. I'm just making that up in the meantime because it's funny.
Just procrastinating it, you know?
I hope we will scare a lot of people away from physics.
Well, are you afraid of competition?
Yes?
All right, understandable.
Everyone's scared. If you don't want to win, all the Nobel Prizes will be for me. It's my backup strategy.
Yeah, it's
Are
exactly.
you taking all the gay people for yourself?
It's survival of the fittest.
Exactly.
No one can take away Remco's Nobel Prize if there are no other physicists.
Exactly.
Ooh. Yeah, I know.
I will create a monopoly on physics.
Like Remco as a mafia was like, hey, nice particle collider you have there. Would be a shame if someone proven string theory was a thing and the standard model was wrong.
I think too many of my plans got revealed in this discussion. I am going to have breakfast right now. Have a good one.
Where did my particle collider go? Here is Remco with an oddly particle collider shaped neck.
Okay, there you go. It's cooking good looking.
Wow.
Ah, there we go.
Okay.
Nah, splendid. I am just so hungry I could eat a breakfast.
Uh-huh. Kid named Breakfast.
Alright, that is cooking in the background. I'm just gonna leave it do its thing. And back to the videos that we are making. Which are
Many videos.
Many videos, yes. Now, this is the next animation. Technically, I wasted some time right here. I could have done it in a more efficient manner, but I didn't, so... Whoops happens. And then also this.
How's your day make it?
My day, with every passing day, I'm becoming less and less stable, and it's becoming more and more difficult to accurately answer that sort of question. I am right now in a state of just manicness, which makes it hard for me to determine how I'm actually feeling. Does that answer your question, Katsi?
Well, it lets me at least segue into my thing, which is that I'm unfortunately older now because I had my birthday like yesterday.
No, happy birthday!
I was so fucking tired I couldn't just fucking busy the whole day, so I didn't celebrate for shit.
I was so fucking tired. Imagine on the birthday
Don't make that joke. You weren't there.
Shut
You
up! I
were
wasn't.
you were there to go for me on my
I
birthday.
wasn't even gonna. I was laughing at something funny. Like, just shut up. Doesn't matter. Oh, I need to make geometry notes for this. Okay, right here what we need is we need to open up the... Oh my goodness gracious me. Is it this one? Why do I have so
You wanna
many?
open up?
Open up a cold can of root beer. Okay, this to 90, splendid. Keyframe and move it up. No, wait, move it down right here, I imagine? Or even better... Oh, where am I
Also, yeah, the all matter GIF is lovely.
It is great. It is great.
It is based off that one fairy GIF, right?
I don't know.
I think you know. I think you may have commissioned that one, didn't you?
This keyframe. Can I just paste it in? That would be nice. No, I cannot. Obviously I can't, that would be too easy. And then these have to... No, they will have to move somewhere. I don't... Maybe right here? There we go. Okay, and then we start with a number like 136, which means I need a number. You work, yes. There we go. $130. Oh, damn it. What's your problem? There you are. 136. Okay, so this shan't be there quite yet. And just render animation. Splendid. What did you send me? Unbelievable. Alright. Now back to what? Yes, back to particle physics, and even more particle physics, and then some more particle physics. I'm new here, so I don't know if this is common knowledge, but what is the name of the software you're using? For the 3D animations, it's Blender. Blender, it's this one. This right here. Would recommend, it's free, and open source, it's great. But, we can combine these objects. So basically, if we start with one SO2 and bring in another one SO2, then when they come together, they can form either a sigma bond or an anti-bonding sigma bond. The anti-bonding sigma is higher in energy, hence why it's anti-bonding, and the bonding sigma is lower in energy, hence why it's bonding. Seems kind of complex. You know, when you go to tutorials or something, there is the classic Blender Guru donut. That's the one everyone always starts with. And other than that, you just look things up as you go. Have you seen the 1000 players rich and poor experiment? No, I have not. Okay. It's bonding. Reason why we get two of them is because there are two ways are underlying. All those can combine. They can either combine constructively or destructively. So that's why hydrogen can bond with itself, but helium can't. Oh. Physics video. Right. This regards everything I've said so far. Instead, we'll have a wave packet on some kind of field. Then, on the other side, we'll have another wave packet on the same field. Why is the sound cutsy? I don't know. I know like cutsy sound. On the same field.
I'm sorry, I was eating. Wanna meow?
Oh, there we go. There is your answer. Complex.
Meow.
The only other thing we have wave packet on the same field. As these two wave packets.
Also, it didn't measure how horrendous they misspelled my name.
Close enough.
I'm surprised you still got it as me.
Close enough. I mean, if you want to focus on the name, you might as well focus on the sentence. Which is not why is Katsi silent, only why is the silent Katsi? That was honestly
It's
the
very legit, very good.
It's close enough. I got the context. They start interfering. And they can either interfere constructively or their face can be off and they interfere destructively. What are you laughing at?
Hold on. You need to see this.
Hold on, I need to mute Discord from saying this. Yeah, that's me, right? That's me. That's a picture of me. Hold on, let me find if I can see.
Yeah.
Oh, and now I want to do another commission of all matter, just drawing me as shit.
Okay. You don't have to spend all your income on all matter.
But I want to. It tempts me too much. Make it. Hold on.
Do I tempt you?
Let me see if I manage to make it this. Hold on, because I need to. Let them spend buy happiness. Exactly. Those who say you cannot buy happiness have clearly never commissioned all matter to do art.
They have clearly never commissioned Cathy to do them. What?
Okay. Now.
What? I mean, it could just hit that pose, I suppose.
I could just replicate it. Oh, whatever. Once I do recording of this video, I'm just gonna make it as Dr. House pose.
Home.
Dr. Homeless shelter.
Doctor Apartment.
I mean, Dr. Homeless Shelter is just like me. Okay.
Okay.
Where are we next?
Well,
Photographers can be off and they're interfere distractingly. Simple as it. As simple as it could be. Okay. Then. Actually, how do I do hybridized doctors then? Most conveniently, I would do it as a plane, but that would require me to spend a little bit more effort on this. And this entire video is meant to be a meme. Resonance. Hi there, Mark. How you doing?
hello. Meow. I look at that high and I knew that's what they wanted to hear.
Damn it, I'm hungry. I am so hungry.
How hungry?
I am so hungry I could hit an horse.
There's especially horse-shaped cat here behind you.
Okay. Superposition residence. Okay, but let's talk about another kind of model.
Am I the only one flustered by the all matter drawing? Not the last one, but the last one, and how I'm like 4 feet in that one.
You mean the rain one?
Yeah,
What are you upset?
I am not that fucking short. Come on.
Are you upset with how? I don't know, maybe you're kneeling.
Yeah, maybe I'm kneeling. True. Wouldn't be the first time.
With that specific pose. It's okay to be shy. Oh! Been summoned!
Oh my god.
Okay, there we go. Alright. This one should be all ready and done now.
Well done.
No, it's medium rare.
Mm.
Medium rare vegetables, my favorite. Times are tough, okay? Times are tough.
The boy slope is hitting quite hard right now, isn't it?
You are spoiling the video. This is... You weren't here, Mark, for the moment when me and Remco came up with this video. But let me just tell you, I'm fine with spoiling this video. The entire premise of this video is that I'm gonna be tricking physicists into learning chemistry. Do you know the Jingle Jingle Markiplier meme? It's effectively that.
I don't think I'm aware of the Junior Markiplier meme.
Oh, it's the one where it goes like, okay, so long before backrooms existed, jingle jingle jingle, oh, I said your favorite word, backrooms, jingle jingle. Okay, so before backrooms were a thing, we had this thing called SCP Foundation, jingle jingle, jingle jingle, okay, pay attention, jingle jingle. We had this thing called the SCP Foundation. And yeah, and it's gonna be the same exact thing but with physics.
Fucking brilliant.
I know it's brilliant. I am brilliant. Are you cooking, make it? Yes, I was. But now I have cooked.
Yeah, we've let him cook.
And now I'm gonna eat what I've cooked.
Mmm.
Vegetables medium rare. Mmm, delicious.
It's medium rare.
Okay, so this is slowly switching from. In this case, we need this to 60. And this should be a seamless loop. Yep. If we reduce the. Okay, right here we have it on 12. But we reduce it to 1, then this is what we get. If we do 100, then this could be also better visible. There we go.
Ooh,
Yeah, it's the anti-bonding.
quite handsome fluctuations. Well,
It's right here actually. And this is a sigma bond. This is an anti-bonding sigma, and if we use, still can't see it, I can just increase the wave number or increase it. Technically, the mathematics would be slightly different because I can't do complex numbers in Blender, but this is close enough. Can I actually do complex numbers in Blender? Hold on, let me see. Quarter. Oh, I can. Quaternions 2 rotation. Okay, but can I do complex imaginary? No, quaternion. We can do rotation to quaternion, but that's not exactly gonna work for us, unfortunately. We could do it in Python, but not here. Okay, splendid. Back to scripting. I'm sorry for not talking, but I'm taking my daily lunch break. This is my one and only time to eat anything.
Yes.
Okay, and in this case we can do
Meow.
620 like this, and then from 0 to a 1. What are you eating? I'm eating veggies.
What are you eating?
I'm eating vegetables.
Veggies. What's your favorite vegetable?
Potato.
Why?
Because this is just. I already said that in the past live streams. Like, potato is what we would get if we could, like, if we would master just crop engineering and, you know, bioengineering and all of that. Potato is what we would make. A vegetable that can grow in any climate, any soil. All it needs to be replanted is just a part of itself. And it's providing us with so many nutrients. It's incredible. 10 out of 10.
Doesn't the fact that we would make them doesn't mean they're good, that they're efficient at being made.
Okay, what is in your opinion a better vegetable?
Better vegetable?
Mm-hmm.
Like cauliflower? Broccoli maybe?
Broccoli!
Why not? Yeah. Why not? Okay, maybe not broccoli. I was thinking about a different one. Fuck. What's the other one I was thinking about?
The only two things
Brussels?
you can...
Brussels,
sprouts.
yeah.
That's just a small cabbage.
That's so much not cabbage.
Brussels sprouts are just a small cabbage.
Well, at least they like taste good. Unlike cabbage, which tastes like fucking flavored grass.
Wait, do you eat your cabbage cooked or not cooked?
Well,
Because if you eat your cabbage cooked, then it tastes exactly like Brussels sprouts.
do they?
Goodness, this is
I really do.
the cabbage is Brussels sprouts is just a small cabbage. Look at it.
That's. You're not gonna say it looks like it, so it is. That's not what you're saying.
No,
Please
I've
tell
eaten
me.
both, and they both taste the same.
This vexes me.
They taste like boiled grass.
No, Brussels sprouts tastes way better than that. That's cap.
Brussels sprouts
think
are
you're getting
genuinely
wrong.
one of my least favorite vegetables.
I think you may be getting wrong Brussels sprouts, man. My Brussels sprouts taste so much better than boiled grass.
You are wild for picking Brussels sprouts over a potato. Quaza, what is your favorite vegetable? Tell me now.
I mean, pickles are so good too. Don't even get me started on the overuse of pickles than just for eating.
It's cucumber if we're going for vegetables. Quaza, what's your favorite vegetable?
It's the same fucking thing, no?
No.
What do you mean?
Pickles are a pickled cucumber, but you don't need something to be a pickle. You don't need something to be a cucumber to be pickled. The defining characteristic of a pickle is the fact that it's pickled, not the cucumber part. So basically, like a. What other things are pickled?
Okay, well then cucumbers, I suppose. Because yeah, they're so versatile. Because they could be cucumbers and they could be pickles, and they're two different things that are both awesome.
You can pickle any vegetable if you try hard enough. Broccoli or zucchini? Okay, zucchini is more like, but broccoli.
Oh my.
You are all so wrong.
At least I can understand it.
I would just like to mention that both of you, one of you picked Brussels sprouts, the other one broccoli, over mashed potatoes, fries, chips, baked potatoes, which are brilliant, then fried potatoes, the roasted delicious.
Every type of potato has this thing. If you put it in your mouth and you're like, start eating it, at some point it just feels unbearable and like you're fucking putting just fucking, miserable.
Every food
Oh,
has
like
that.
the top of your mouth.
It's called being full.
No. It happens with potatoes way sooner, and it's just fucking annoying and sucks always.
You need to chew, not only swallow.
It just feels really bad. I don't know what's up with potatoes, but they just feel awful on like the top of your mouth. After you eat like a couple of them, they just feel abysmal, specifically up there.
I can say that
It's something with fucking potatoes, because it happens even with chips, which I mean they're like very processed, but even with chips it could happen, which is weird.
Personally, my top mouth doesn't have any issues with that.
I'm not gonna continue that joke.
But cauliflower is an F tier vegetable.
Why?
Because it's basically it's basically an albino broccoli.
But,
It's broccoli
yeah,
but without the taste.
It's bigger.
It's
bigger.
But it's broccoli without the taste.
It has a taste if you boil it.
Just
it
because-
definitely has a taste.
Boiling removes taste. What do you mean?
No.
That's the opposite action you should take.
No, that's how you fucking do it. No. Oh my god.
Boiling removes the taste. It's awful. It makes certain foods safer to eat. But unless you're making a soup, in which case you need to add seasoning in order for that to be a soup. Because if you don't add the seasoning, it's just It's just water with the
Imagine
essence of
so
death.
so mushy, so juicy though.
Cauliflower are just objectively worse version of broccoli. And potato is just the
Broccoli
best
is-
vegetable, and you all just don't know what you're talking about.
Broccoli tastes so much worse compared to cauliflower, and it's smaller.
I think you just hate the. I think you just hate flavor and taste, and the sensation. Like,
Remember, you eat
I
fucking
love-
mushrooms raw. Shut the fuck up. Don't
I
think you love it
I
food
love just-
poisoning and
I-
shitting out of your ass.
I love tofu. My favorite taste. It is. You seem like the kind of person who would really enjoy plain rice.
You enjoy plain rice.
I don't know. I add sauce to it specifically. I eat plain rice when I'm hungry. And I don't have anything
plain
else, but
rice,
that's
no.
more like
However, rice with cinnamon is fucking goated. But that is because cinnamon is fucking goated. I don't think that's rice part. Actually. Well,
potatoes. Potatoes are just the best. Objectively the best. Any other vegetable pales in comparison.
they're only good if you're in Ireland in fucking 1870. Every other place they suck.
Do you like fries? Yes, the answer is of course you do, because
Rarely.
everyone loves fries.
Depends how you fucking make them. If they're like crispy fries, yes. If they're soggy fries, they're so
You
fucking
see,
bad. It's
the reason
unbelievable.
why you need to say depends how you make them.
And if you
And can't
and you
just
just
say
put
no.
them and you leave them, you don't eat them immediately. They get soggy by just fucking being out for fucking air moisture, and they become bad fries if you just don't eat them like immediately as they come out.
Maybe if you're getting fast food fries, then maybe yeah, but not all fries.
Well, fast food fries aren't even that bad. It's the fucking shitty like off-brand restaurant fries that are the worst.
Honestly, this is actually a great sign of great vegetables versus shitty vegetables. Unless you cook it yourself, no restaurant would ever give you Brussels sprouts. Unless like a very hyper-specific order. And you know why? Because they only appeal to the people who hate fun, hate flavor, and love the taste of boiled grass. You know, I'm starting to think, Katsi, that when we made the bet where you had to eat grass, you just wanted to eat grass. You just didn't have any Brussels sprouts. Oh no, I lost the bet. Guess I gotta eat them now.
No,
Brussels
I'm not a cow. Whatever
sounds
the
like
popular opinion
something.
might you believe, I'm.
Sounds like something a cow would say. I'm starting to think that wasn't a horse-shaped cutsy, it was a cow-shaped cutsy.
Oh, you're pulling on my others.
Oh my god, no, you ruined it.
I will eat it first.
Honestly, I can't believe. Broccoli? I don't...
All matter, are you still here?
All matter, what's your favorite
matter.
vegetable? We need input.
All matter, no. We need a fucking drawing of like me as a cow and make it making.
You want that? Pay
Now.
them! Pay them, you can! I refuse to...
Don't you he's here.
I refuse to...
Don't you fucking dare me.
I refuse to ask Olmate for anything since they have fiber. I also never made fun of potato, by the way. That's why I respect it. Like, Brussels, you know what? Broccoli. I still think it's a very odd choice for a favorite. It's only odd because, like, the thing is, to me, what makes a vegetable best is how long could you eat it before you got sick of it. And when it comes to broccoli, I imagine after 3 days I would be done. When it comes to Brussels sprouts, half an hour, and I would just be it would be unbearable.
You're crazy.
Tomatoes are a strong contender simply because you can prepare them many different ways. But I still would get probably sick after like 2 weeks.
Tomatoes? Eh. I mean, they're good. They're good if you prepare them, but like.
Potato is my unhealthy
Okay,
favorite. Just,
wait,
what do you
no,
mean
it's like-
unhealthy? They can be healthy and prepared, right?
No, we can't. No, you're wrong. Fuck you, you're wrong.
Oh my goodness, you just... Honestly. Quasar, you spend too much time with weird cuisines. You know how to cook all the weird shit. You need to now remind yourself how to cook the basics.
Are you
Unbelievable.
food shaming him now?
Yes, I am. I will not have my beloved potato be called unhealthy.
There is no way we can be food shamed by a person who fucking eats fucking frozen cooked veggies for like half a year and drinks fucking
Blue.
cursed coffee that just like should be fucking allowed for animals even.
Potatoes, I prepare them in an unhealthy way. But see, that's the problem. You can prepare them in a healthy and delicious way. I genuinely baked potatoes. Beautiful, if done right. I really love both potatoes and Brussels sprouts. I shan't accept that. I need a extremist answer. We need to be divisive issue. Who in the right mind would pick Brussels? You know what? I don't even. There are so many strong contenders. Potatoes, tomatoes. I would get that. Cucumber, banger
I
choice.
think you just like. Fuck, I'll say animals. I think you just like vegetables that have toes in their name. For no particular reason.
Oh yeah, let's not get into why I like cucumbers. But, Megan, what's your least favorite veggie without saying Brussels sprouts? You see, it's difficult because when it comes to my least favorite vegetables, there are vegetables that I don't eat. So I need to be actively reminded of them. And so right now that is Brussels sprouts. So I need to actually think
Oh
some more.
my god. This fucking guy.
And hold on, I need to.
But
go
but
through
you
my
like
mind
cabbage apparently somehow, but you hate Brussels sprouts. That doesn't make any fucking sense.
I don't love cabbage. I tolerate it when it's cooked. Raw cabbage just tastes like a raw grass.
I mean, yeah.
Hold on, I'm thinking about vegetables. I need to look up the list of vegetables.
Is spinach a vegetable?
Yeah. But I like
Oh yeah,
spinach.
fuck spinach.
I like spinach. Because spinach...
Well, you eat fucking slop. You eat fucking nutrient paste, so you don't count.
Is there like a list? That would be great. Can I have a
Spinach,
list
spinach
of...
is a nutrient paste of vegetables.
It is, but it absorbs seasoning really well. Alright, cabbage, lettuce, broccoli, spinach, potato, radish, spice,
Oh, you
celery.
can name every vegetable.
Let me think. Pumpkin. I don't enjoy pumpkins. But I wouldn't say I hate them. Endive. Ooh, that's a strong one. But they can also be cooked, yeah.
Endive.
Leek. Oh, I think it could be leek. I think my least favorite vegetable could be leek.
But how dare you? But Hatsune Miku.
Yeah, that's exactly. Big leek had to like literally hire Hatsune Miku in order to make their product appealable. Because of how unedible it is. Most of these would be delicious in the soup. Oh, corn is another. Like, when it comes to the ones I would expect people to say they're good, that would be like corn, potato, tomato, cucumber.
Corn has its place in the world, in a salad. Or in popcorn, I guess, but popcorn is It tastes good, just as bad fucking design.
Waiter, my gourd isn't bitter enough.
Shut up.
Where's the
My ginger.
drumstick? That's not real. That's not a real vegetable.
Drumstick. Apple gourd.
I like
Fucking
how I like
pick a fucking lane. Are you vegetable or fruit?
I like how they started with icons and then they just like just run out. So mushroom is just a picture of a mushroom.
Yeah. Yeah.
No, I think it would be leeks.
Wait.
If I had to pick like
Oh, chili. Oh god.
I once again I consider
Why?
vegetables of how long it would take me to get sick of them. And
Okay, how long are you sick of eating fucking red chili peppers?
you don't want to ask me that question. I will like because red chili is something I eat raw when I'm sick. So two reasons.
Ex-
First of all, it does wonders for your stuffy nose. And second of all, oh, you can't taste? Now you can. Yeah, you can. You very much can. It's great.
Oh my god. You are a specimen to be studied for centuries.
We need a vegetable tier list. That's what we need to do. Vegetable tier list. And we're gonna do a tier list of how long. I'm gonna do a tier list of how long it takes me to contemplate the vegetables. How long it takes me to get sick of a vegetable. Well known labeled. Alright, so first, S tier, that would be like possibly never. A month. A week. Days. Day. Hour. Wouldn't even formally. Alright. So artichoke. Oh, but then again, preparations matter. Like all of these raw would be so much different from all of them cooked.
Artichoke. There is a joke to be made here,
Good for them
and I don't like it.
if they're into it. No, I felt it would give me a couple of days. This one, I don't even know what this one is. But it looks like grass, so I imagine hour because it is just. Oh no, I know which one it is. It's grass. You can't even cook this one. Wouldn't even for money. That is just grass. If you want to eat grass, go eat grass. Honestly, don't bother just naming it. That would just make me attached.
Next time I lose a bet, I'm going to buy Argula.
Asparagus. This is just grass. Argula is just grass. Asparagus is not bad.
Yeah, it's not bad.
Avocado. No, I feel like also days. Beans. I give them a day. They all have such a similar taste.
I'm British, mate. I'm British.
Beet, once again, beets could be good actually. Beets I might even do for asparagus because
they will fuck up your clothing if you drop one, but they taste okay.
Avocado prepares guacamole lasts a long time, but that's my problem, Quasi. You see, when it comes to guacamole, right? With just avocado, it would be horrible. It would taste like butter.
Butter?
Like,
I barely know her.
A lemon and chili stuff would make avocado delicious. Bell peppers in a soup, I imagine I could pull it off. In a sauce, I could pull it off. Broccoli, also I imagine actually probably days. Brussels sprouts, I can barely stomach them as they are. Button mushrooms, I like button mushrooms, and if I can eat them forever. Cabbage, yeah. Oh, maybe with the 4 beans. I imagine I could do a day of eating cabbage. Carrots. Carrots are good. I just personally don't enjoy them.
Are you a horse?
No, I don't enjoy them. What is cassava? I don't know what that is. That looks like a tree bark. I don't trust it. Cauliflower, just objectively worse version of broccoli.
You're a bad person. You're objectively a bad person.
That would be this. Celery. That will also be this. Chard. So that is chard. Let me think. Could you cook it? Because if you can't, that's just grass. Chili pepper. I feel like I could do a day on chili peppers alone. That would be an enjoyable day. I'm gonna rate it above cabbage. I prefer like cacophony of taste over lack of taste. Dollards, I do believe this is.
That's not a cacophony, it's just your mouth burns and now you feel like you're going to die.
Yeah, I take that over just ennui and boredom. What's crazy, like the vegetable alone or prefer something? I imagine all of them mixed together. So like we're trying to average out, right? Average out the vegetable on its own, cooked.
Your
and all
type
that
of guy
stuff.
who would eat anthrax for the taste.
Hold on. Anthrax. I would try it. If someone offers it, maybe. Collards,
Oh my.
if I remember correctly, collards can be actually cooked, and they are actually better than the cabbage. So here we go. Corn, that's easy. Month,
You never heard of Brussels sprouts. There's no
Becomes-
Brussels sprouts can be cooked. I swear to God.
mommy. This one. Yeah, eggplant would go below avocado. It could be survivable. This I
At
don't
least
know
there's
what
some
it is.
overuses.
I don't know what this is. Fava beans. Oh, they are bloody delicious. I would do it, man. I once got so many of them. I actually did manage to last like a couple of days eating nothing but them. They are good. Fennel, it sounds posh. Garlic. I would rate garlic a little bit
Fennel?
above chili pepper because I feel like it would be very similar as an experience, but it would be a bit easier to last it.
I think garlic would be fine.
Green beans are delicious, and I would put them above beet. Actually, maybe below fava. Yeah, I feel like right here. Actually, fava beans below. Jalapeno, that would be. I think I would prefer jalapeno to a carrot. How long could I last on jalapenos alone?
You are an individual, to be sure.
Oh, let's do day. Kale, it's an absolute joke. No idea what this is. A leek, absolute leek goes to the very end. Horrible. It's the taste of grass, except without the texture. It's honestly incredible. The scientists, the vegetable scientists who make all the vegetables, they've done an incredible job when it comes to making grass even more unedible. Honestly, I didn't think it could have been done, but then they created leek, so that's good for them. Lettuce, just objectively worse cabbage.
Objectively worse grass.
Lotus root, no clue. I don't know. No, nori, nori. I feel like I could do a week. No clue. Olive. Olives are solid, and they would be similar to fava beans for me. Snackishly, delicious. Onions. Onions, once again, I feel like a little bit below.
Are
beet.
olives a vegetable? Where the fuck do olives come from?
The olive trees. Have you ever heard of an olive branch?
Uh,
That branch is attached to a tree.
Why are they in a vegetable then? Excuse me? Why are they on this to-do list?
I mean, because there are vegetables.
Vegetables don't come from trees. Am I going
Is it-
insane?
I don't know if it's an olive tree or a bush. So before we keep going, I'm gonna check olive. No, it is a tree. That was correct. That's good.
That-
But why can't vegetables come from trees? Who
Because
says
that's
so?
what fruits are. Fruits come from trees.
I'm gonna strangle you to death.
Am I going insane?
It's not mutually exclusive.
Yes.
You'll be surprised to know that olives are both vegetables and fruits.
What?
Right, plantain. I don't like the idea of something being named after being
You're
plain.
insane.
Potatoes could go forever.
It's a
Pumpkin,
fruit. You're a clown. You're a clown. You're such
I
a fucking
swear,
clown.
you just don't listen.
Okay.
What did I say, Katsi? What did I say? Repeat to me what I said.
Okay. Well, look at this. Look at it. Bruh. It's literally like, oh my god.
Okay, Katsi, repeat to me what I said.
You said they're both.
Yes, vegetables and fruits are not mutually exclusive.
How so?
Because
I know-
vegetable is a
like-
culinary term and fruit is a botanic term. That's kind of like me asking you if a yacht is a boat or a vehicle. Which one is it, Katsi? Is yacht a boat or a vehicle? It's fucking both.
I love how Cass getting Mike get railed up, and he's getting me railed up. We're not the same.
Italian.
I don't think you get the joke anyway.
Shallots are slightly inefficient onions. Shiitake, what is that? Is that a mushroom?
So what the fuck is a vegetable then?
Vegetable is basically a group of like roots and fruits and all of these things that are not served sweet. If you serve a non-animal in a way that's not sweet, that's a vegetable.
What? It doesn't mean anything.
That does mean something, because that means that if you have a salad made out of vegetables, you're not expecting it to be sweet. Well, if you have fruit salad, in which case you specify fruit, also because fruit is also can be a culinary term, as it being a non-vegetable salad, then you're expecting it to be sweet. Shallots as inefficient onions. They are inefficient onions. They're just
Aren't beets sweet? Or am I going insane?
Beets are. You can make them sweet if you want, but normally they're not sweet.
Are the sweet potatoes also not sweet?
Why is leek there? Because leek tastes like grass and it has even worse texture. Shallots are basically hyper-condensed flavor onions. Yeah, but I call them inefficient because they're small. If I go to the store, I don't want to buy 7,000 shallots. Also, I consider them posh food. Just like sweet potato is a posh version of a potato.
Sweet potatoes aren't sweet even. I'm losing my fucking mind.
They are, but they're not traditionally served like as a dessert.
Fuck you, dude. Cooks have to be shot. All of them.
A plant cultivated for its edible parts, such as the roots of beets, the leaves of spinach, the flower buds of broccoli, or the fruits or seeds of certain species as beet, corn, and squash. Except, you know, mushrooms are also vegetables, so.
And also sweet potatoes, which are sweet, which are an exception to this definition, but okay, whatever.
Member of the vegetable kingdom, especially green plant, once again.
Because we fucking love making exceptions.
Make it has no taste, shame. I don't like things that aren't.
Cooks are like physicians. That's why you like them. Or like chemists.
I haven't actually eaten turnips.
Turnip. Turnip is.
Yeah,
No, actually, that's not. I don't know anything about. Radish is good. Turnip, I don't fucking know.
Sweet potato is a posh version of a potato. It can go piss off.
Yeah, but no, sweet potato isn't a fruit, sorry.
Ruling out tomato basically rules out pasta. I mean spinach is a surprisingly good substitute. Should be an auto and Estia. That's effectively a flavor town for so many dishes. Yeah, but like but the reason why I was going to put onion on Estia, but then when you think about it, like imagine you had to only eat onions. Like onion as a supportive thing is great. It's definitely Estia. But then when you also consider eating only onions, you would go mental. So like for example, the reason why I write tomato so high, right, is because tomato in a sauce is delicious, in a soup it's delicious, raw is delicious, and then on its own, you could still eat it for a long time, you wouldn't get sick of it. I don't make it ever caramelized onions. I have, and it's caramelized onions are good, but after like a month of eating them, or like a week of eating them even, you would go mental.
Can you caramelize me?
I would need a really big blowtorch.
You have a blow. Does that count?
Wait, hold on. Quasar, you said broccoli, right? Yeah, there we go. I put broccoli under carrots, and I don't even like carrots. That says a lot. I'm looking back now at it to see where I put everything. I don't think you should order them based on the thing alone, how well it goes into dishes. Yeah, but the point is that I'm rating them based on all of them, right? Or them alone, them in dishes, them supportive. Like, listen, if I was just ordering them based on how they taste alone, right, then cucumber would be way higher. Because I don't think, when it comes to eating vegetables alone, tomato and cucumber would be just first place.
Isn't the whole point of the tier list is you eat them alone until you're bored of them?
No, I said in the very beginning that like I'm averaging out everything.
Okay.
Solid dish, onion and garlic would be top 2. Based on solid dishes, chili pepper would be top. Because holy shit, everything basically, like, the reason why chili pepper, jalapeno, and all of those got rated down so low is because if you had to eat them on their own, that would be torture. Hold on, how is the animation doing, by the way? Oh, there we go, it finished, splendid. Oh yeah. In this case, this had to be on. There we go, hold on, I got a message. Mexican Persian food. Korean, Japanese, Mexican, and Persian. Those are so similar. Listen, considering how Quasar likes Mexican, Persian, and how Yuremko like Korean, Japanese, I wouldn't want to taste what you would both make together. No, on your own, I would love to, but together, that worries me. Nick is definitely a lost cause. Not my fault, you just pick some weird posh things as top 1. It's ridiculous.
I think it's literally your fault.
Okay, Brussels sprout lover, you don't get a choice. Oh, hold on. Let me name my you know, those famous dishes with Brussels sprouts that everyone loves, like for example,
Like soup with Brussels sprouts and a bunch of other shit.
And a bunch of other shit being the crucial carrier there.
Well, I always eat Brussels sprouts first because they just taste the best out of everything in the damn soup.
No culinary imagination whatsoever. Culinary imagination is for people who have the money to do that sort of thing. I eat food to eat it, not to play with it. Oh yeah, let me just go to the supermarket and you know what, let me get the sweet potato that's twice as expensive as a normal potato, because I just shit money wherever I go.
Didn't you just pay for like an overall matter commission?
Yeah, that's where all my money goes, not to fucking food. Ridiculous. It's the meme of like the guy, hold on. Where's the meme template? Wait. Ah, damn, I can't find it. Like the template of money going to the rich, and the rich is just labeled all matter, while the poor is just like food.
Yes, I know.
Imagine that maker somehow sustains himself. Yeah, I cook things in order for them to be edible and min-maxed for. Basically, I'm trying to make it as cheap as possible, with it still having some taste. No, buckets of raw tomatoes. They were on a discount. That only happened twice. No, listen, I'm sorry, I don't speak posh. Yeah, oh yeah, let's add shallots to our meal. Oh, would you like it plated on a golden platter or just a platinum laced with diamonds? Unbelievable in this economy. Nickel platter. Sorry. Oh no, yeah. I need some coffee in me. It's ridiculous.
which is fine.
I bet make it eat raw garlic and onion because cooking is posh. No, because garlic and onion are cheap. You know what's fucking funny, Remco? If I open my fridge right now, the only two vegetables I have in there are garlic and onion. This is the only two vegetables I have at the moment because everything I are using sauces. And you know what? I'm gonna eat a raw onion just to spite you. You didn't put them in got yet? Yeah, because garlic and onion on their own aren't good. Have you ever eaten just onions? They're not great. Have you just ever eaten just garlic? Raw red onion, my goodness. Yeah, I bet you just eat it with golden flakes sprinkled on top. Classical example of the bourgeoisie just shaming the working man.
I love the new bit of everybody comes into stream and obliterates make it on his ridiculous fucking taste in vegetables.
Okay, Brussels sprout cat. Fuck, I was gonna say that actually stopped me for a second. Good boy, good girl. I mean, good datum. Raw garlic is great if you want to taste anything for a week.
No effort to make it because he can't taste anything anyway.
No, I like spicy.
Doesn't
I
it
like
finish-
extremely spicy things because if you're like min-maxing a meal, you have three factors to take into account, right? The taste, the healthiness, and the cost. And if I'm min-maxing for the healthiness and I disregard the cost most definitely, and then a little bit of the taste, making the food spicy is just a easy cop-out. It's great. Present discussion, Mickey does not this at all. You've seen me cook. Your opinion was very much different when you've seen me cook. Do you use salt? No, I don't use salt. I use I don't know what it's called actually.
That explains thing.
I use. There's like a very. It's not exactly soy sauce. And or pepper. No, I don't use pepper. Instead of pepper, I used. I use hot red pepper. Dried hot red pepper ground down.
Nail stream. Yeah, I think that's it. I think that's the thing.
I reckon you will make it remove Remco. Remco got kicked for radical opinions. Wait, what are we disagreeing on in this case? Hold on, because I was about to debate radical opinions like for example with Kathy, I can shame Kathy easy for thinking that fucking Brussels sprouts are the best vegetable, which is idiotic. But what are
I'm
you?
not
What
fucking
is
Brussels sprouts. I'm fucking making that's the difference.
what is your argument, Remco? Here, what do you have a problem with? And also, you Quasar, what is your problem, Quasar? Oh yeah, Quasar's problem was that I ranked onions higher than shallots. Mr. Money.
See? Remco gets it.
Your lack of taste. What do you mean lack of taste? Okay, I ranked tomato and potato as the two best vegetables, which they are. Just because you are delusional, all of you are delusional, and think they aren't,
Yeah.
that's not my fault.
Yeah, everybody's crazy. I'm the only rational one.
Best vegetables? Yes! Potatoes and tomatoes are best. The red was best. Yeah, it was. The red was. Your ranking was. Well, the ranking was how long could you eat a certain vegetable before you got sick of it. And I said that you could eat potatoes and tomatoes the longest without getting sick of them. Which I think is true. Because if there is a person on the planet who gets
You
sick,
rank red peppers as a day, as you can eat them for a whole day and be fine.
the chili peppers.
Yes.
Yeah, I rank them above cabbage. I would prefer to just eat red chili peppers for a day over eating cabbage for a day.
You're a skinwalker.
No, it's just that I prefer to taste things other tasting boiled grass. That would be not fun in the bathroom. That's why I ranked it day,
Red
because
hot chili
eventually...
peppers aren't tasting things. It's like putting fucking hot embers in your mouth. That doesn't mean that's not a fucking flavor.
There is flavor once you get past it. It tastes like a normal pepper, to be fair, but it's still flavor. That's why jalapeno is higher. Jalapenos
God.
taste better.
Ah! You bother me.
You pick fucking Brussels sprouts!
I am proud. I'm a proud Brussels sprout eater.
Honestly, you cannot name me a single meal with Brussels sprouts in it. I know you can add them to soups, or you can make them on their own, but I cannot name you a single meal.
Okay, new thousand stream idea. You cook Brussels sprouts.
Cooking Brussels sprouts effectively just means heating them up. That's how you cook Brussels sprouts. It doesn't even matter in what way you heat them up, because it's always gonna taste the same.
Oh my, this fucking dude.
Brussels sprouts. When you want to eat a cabbage, but are scared that it's just too spicy. And spices are another rough thing, because with enough spices, I could make cardboard taste like a goddamn... I don't even have a hyperbole.
Wow,
The
so good.
reason why tomatoes are so high is because you can use them for delicious sauces. And if you have a good enough sauce, you can eat cardboard with it and it will taste delicious.
I finished that is like cardboard with a hint of sauce.
What do you mean a hint of? Oh yeah, sorry, I forgot. You eat Brussels sprouts. You're not used to flavor.
I mean, yeah, of course, if you like just eat tomato sauce with a slight fucking amount addition of cardboard, it's rather like tomato sauce. No fucking shit.
Pasta
That's
on its
not like an
own.
argument.
Pasta on its own almost doesn't have almost any taste. The whole
It's
point.
a better taste than fucking.
It doesn't have taste. It has a better taste than
Yes,
Brussels
yes, it
sprouts.
Pasta on its own definitely has taste.
In one case, there's a guaranteed survival rate. Quasar would just do some posh BS with shallots and sweet potatoes and fucking, I don't know, weird mushrooms.
You drink raw sewage.
It's cheap. In this economy, yes. Another forbidden kind of good love. Would you cook with spite? I cook with desperation. If I had the money to fucking cook for myself what I wanted to, that would be something. But each commission with color, but each commission with color and shading from Almaty costs 30 euros, so that's not me.
Okay, buddy. You don't need to call and train on everything.
I need more coffee. Alright. of common examples, this would work a fair bit better. Unfortunately, we don't have them. To make do what we've got. Okay. What is 136 in binary? Decimal binary.
3, probably. No, it doesn't. Sorry, man.
I can send you a picture from them. Oh yeah. Doesn't Renko have access to the philanthropist? Uh, 136. We might run out of space here a bit. Oh wait, no, we can't render the other one. This one's still going. In this case, we'll need a resonance, an example of resonance, which carbonate, you say? No, carbonate may also refer to a carbonate. Okay, so it is just resonant. Splendid. In this system, we have
Meow.
one particle middle. Let's call it C, and 3 identical O particles around it. Hi, Araf. Hi, welcome. These particles are together, and due to the action of a bonding named after James Bond, the C particle can bond once with 2 of them and twice with the third. Now here's the question. With which it will bond once, and with which will it bond twice? What does that make it? Not much. Working on the videos. 3 of them at the same time. It's really slow. It's going really slowly. I won't lie.
Oh.
Yeah, unfortunately this video, hopefully able to finish quicker.
You're always able to finish quicker.
Unbelievable.
Meow.
Hi Macaroni, how you doing?
Macaroni. What's your favorite vegetable? That's crazy. Meow. What? He isn't here now.
What do you think about the comment in quantum mechanics to become chemistry viz? They say there were some errors in the explanation and understanding of some of the concepts. Which comments? There were quite a lot of comments. You need to be a bit more specific, Araf.
Alright, should work now. Good. You were saying vegetable.
Yes,
Yes.
So potatoes don't count? Those aren't vegetables technically?
they are vegetables because they are part of edible because they are edible parts of plants.
Alright, if we say that's a vegetable, then potatoes.
I'm leaving the call. You'll never see me here again.
What? What did I do?
Katsi is just wrong, objectively so. They think that
What?
Brussels sprouts are the best vegetables.
Oh my god. Oh
That's
my
what I'm
god.
saying. Unbelievable.
Absolutely unbelievable. Get a load of this guy. Or gal. Guy in the gender neutral term.
Good boy. I mean good girl. I mean good datum. Nice. How do I actually? Do I need to explain resonance for this?
No, like Brussels. No, but I generally don't like vegetables. Generally.
Like you don't like the taste or just oh,
Texture and taste.
Oh, okay.
Fruits and vegetables aren't really my thing. It's just.
Just hate plants.
Yeah.
Those green fucks. I get it.
Planters.
They're always. Oh my goodness. Yeah, I mean, I get it. They're always in the way. Recently, I went just for a walk. I was trying to enjoy a nice forest. Couldn't see it. The trees covered it all up.
Yeah. Absolutely.
So
Jarvis, see the forest for the trees.
Not this again. Hold on. There's a comment by a guy named Kira PH1234K. Let me see. Let me try to find the comment. Kira.
Have this terminology over my head.
Can I search? Could you give me like some keywords in the comments? Or actually, hold on. You said the quantum mechanics becomes chemistry, so it's becomes chemistry. Write your comments, and it is Kira. Okay, Dexter, come on. Spencer, free in the siege.
Chess, very insightful commentary. Also, my favorite part of the charity checkups is when he checks up on a charity. Oh wait, no. Roll for pronouns. Your gore. We got a 78.
I can't find the it's limb.
Lim. When Lim checks up on the charity.
Oh, I think I found it. Checkup, yeah, okay, I think I found the comment. So far, you've got a many aspect confusing and notable. You claim that you cannot know the position of the particle. It's incorrect. It's even encouraging public which could state that there are pairs of information where knowing more one part gives uncertainty about the other. One such pair location velocity as knowing the exact location of a particle if we also have information about its velocity. Yeah, that's what I... Oh my goodness. Okay. Thank you so much for rephrasing what I said. The wave function, specifically that you represent as means particles only exist in superposition where more than one result has no zero probability. Well, you didn't use the word superposition. This is exactly what you are saying. Just isn't accurate. There are many situations in which the particle's wave function only has one result probability. Most situations, in fact, as this happens when the particles from interacting. You represent as means particle only exists in superposition where more than one result has non-zero probability. Two is not true. Well, that's just nice. 3. You mentioned tunneling and described it as absolutely incorrectly. You claimed it tunnels through an impassable barrier, which is entirely wrong. We can and have made the barrier impassable and tunneling doesn't happen. Making the barrier tall and wide lowers the probability of tunneling to 0. This person is unbelievable. Even just making the barrier tall and wider lowers the probability to 0%. Tunneling, by its very definition, can only happen through a barrier which is actually possible to pass through and or around. Wow! You mean to tell me that when I said it passes through an impassable barrier, that the barrier isn't actually impassable? Crazy!
What?
I'm going to... What replies?
Krill this person.
If Ring has a mega 10% not production principle, has a mega 10% correctly implies the product of the chemical particle precision. While you're generally correct in that manufacturing of knowledge, even if still finds say one observable J supports in respect to observables. For example, say 100% user. Tunneling is by definition a particle passing through a classically impassable barrier. For example, an infinite potential is quantum. Yes, exactly. Oh my goodness. Particle is possible from a massive perspective. It can look like it. It's important to consider the context of the video since this is our communication. I mean, Tobias. Thank you. Tobias just got it spot on. I mean, Tobias just got it so unbelievably spot on. Oh, I love you, Tobias.
Free is off by saying, what do you mean by classically impassable barrier? What do you mean by classically? What do you mean by impassably?
No.
And what do you mean by barrier?
No, the Jordan Peterson within is breaking out. Quick, someone stop him. No, but this is
Someone
actually
send an army of libs.
exactly spot on. I'm going to mainly focusing on the third point because that's what struck a nerve with me in the first comment. But that's precisely what I meant. Classic. When I said passes through an impassable barrier, I meant classically impassable. As such, you need to use quantum mechanics because in classical mechanics it wouldn't make any sense. It doesn't teleport. I do believe, if I remember correctly, that the words I used is exist through it, which I think is the best description of quantum tunneling I could have given. The particle isn't really teleporting through it, it isn't really going through the barrier, it's just like existing through it. Its probability just spills over. And let's see. Correct, and in the wrong principle, the first bring a superior doesn't imply that certainty can never be 100%. That's going inside of the principle for application of finite precision measurement. Sorry, what? For point 1, you're absolutely correct. I named the wrong principle. Yes. Though Heisenberg's uncertainty principles doesn't imply that the certainty can never be 100%. That's going outside of certainty principle to follow the implications of finite precision measurement? Do they mean that technically Heisenberg's uncertainty principle doesn't mean you cannot be certain? I mean, yeah, if you have no idea where a particle is, it doesn't imply that the certainty can never be 100%. I think what they mean is that technically Heisenberg doesn't mean that you cannot know something. But I mean, in order for one of the deltas to go to 0, they're proportional. The other one would have to go to a limit to infinity. I think you missed what I was saying. In order to get into suppression, we must isolate the particle from observation. This is rare in the real world for the particles in the universe, which add the constant observation to the existing amongst other particles interacting. Have to take care to craft superpositions with multiple state probability. Physics longer than most. I don't understand the contrast between classical and quantum. It's strange to talk about modern day where we all learn physics informed by standard model, relying on contrasting against what seems classically impossible to explain. Quantum concept doesn't help people understand it causes confusion. Tunneling isn't teleporting. Fusion search to actually talk about something simple the point of being measured precision of the present doesn't have understand at all. These to hold incorrect notions isn't far from simply sensing representation. Communicating with accuracy as predictive is given no matter justification which item believes by any chance of understanding. I think Kira just really wants to be in the right, because tunneling is teleporting in my opinion, but teleporting is not tunneling. I like Tobias. That Tobias look. Why is it paste 2? At Tobias rocks.
Rocks?
I was going to reply to the original comment clarifying everything, but you got it spot on. Thank you so much. You really do rock. There we go. Duh. What is this comment? Don't just marry me based on the voice alone. Not a good idea. Should look for set your standards higher. Wouldn't teleporting be simultaneously disintegrating and reforming your particles in a different place altogether? With that definition, you can think of quantum tunneling, because I mean it's just moving a particle in that case. I mean, teleporting is rough, T-concept, because it's not something that exists in any way. We don't really have a coherent idea what teleporting would mean, simply because we haven't seen it. Like with our typical intuition of teleporting, it would be like instantaneous transmission of communication, instantaneous, movement of information, which cannot work. So simultaneously disintegrating and reforming our particles in a different place, I suppose I see what you mean. That could even work. But yeah, it depends how you define teleportation to skim around physics. When it comes to the density matrix, even you have to worry about point 2. If only a density matrix, right? It's a spatial replacement of a state that destroys the original states. I just don't like thinking of like quantum tunneling as teleportation, because like the particle then teleports without quantum tunneling as well. I just really like to think of it as particle existing through a wall. It's just really nice to me. I like it. You have a.
I just think you're neat.
I just think you're neat. Just particle. To me, it looks like when like in Blender. Hold on. This is a horrible example, but in Blender when you have just an icosphere, just like moving through a wall. At no point is the entire sphere in the wall. That's how I think of quantum tunneling. It's not perfect, I know. The original because of the world state actor breaking.
Makes sense.
I think the original state observation. Oh, I see. I suppose it would be by definition teleportation then. Okay, in this case, I do believe that the wave number of 1 will be more accurate than wave number of 100. But as I mentioned, I don't really have access to complex numbers in this case, which means unfortunately we need to do it this way. Sometimes on stream with some preparation, the density matrices or quantum tunneling. Oh yeah, this is messed up. Well, it works in some way. Quantum
Today on
teleportation.
how fucked up is fucked up. Yep, that's fucked up.
Yes, okay. Back to the video. This actually would make a lot more sense, I think, after the Feynman diagrams. Well, Feynman diagrams in quotes, because, you know. Next we have the skeletal structure organic molecules. Feynman diagrams! This is such a comical stretch. There's a quantum certainty that sees energy from the vacuum for a sec. You're gonna make any videos on organic chemistry? I have already made a couple of videos on organic chemistry, and I will probably eventually make some more. If we keep going with the series like we're going, eventually we will reach organic chemistry, and then I'll expand on it. Okay, you know what, everyone? I am getting a bit exhausted. It's been 4 hours of solid work. So I am going to go now.
Weak.
I'm gonna go and have a break, then work on some videos some more. And, well, there's either going to be another live stream today, or I'll see you tomorrow. And for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye!
See ya.